Yes, yes, yes. Okay. Who is Amit? Yes, yes, yes. मेरी फोटोज में तो हो गया ओके प्रेजेंटेशन यस यस ओके 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 ओके
बस आप यही रहिए
Hello. Welcome back, everyone. I hope you enjoyed a delightful lunch. As we resume our proceeding, let's carry the positive energy from our meal and to proceed further. Here we are starting our industrial speeches. And first, I'm asking Pioneer to provide the speech. Thank you.
hello hello good afternoon everyone. My name is Parth Patel. I'm from Pioneer Foundation Engineering Private Limited. So we are from 30 years. So we work in different projects in the different state and the different locations. So here I'm going to represent one of our major and very important project, Atal Tunnel Slope Stabilization and Avalanche Prevention. Okay, so we can see we have we done the Atal Tunnel project in Himachal Pradesh, which is around with the 10,000 feet height of the mean sea level. So it's around 9.4 square kilometer under. Uh, it's a tunnel passing from the Manali to Siri location, which is reduce the 45 kilometers distance between the Manali to Siri location. So we done this project starting from before 2 years. So we complete this project. So our main project work is in this project with uh, sinking the soil erosion and the valley side soil erosion and the high valley side soil erosion. We our work is to stop this erosion basically. Connectivity is the key growth of development of society. So you can see this is the Atal tunnel. So this is the high valley side, and there is the low valley side. So here we can see this is the tunnel. Okay, this is the south portal. So our work is here the south portal, and this is the north portal. Before this tunnel we have a one route from Manali to Siri beach, so we need to follow this route before this project. So this route is 6 month stop because of the avalanche, uh, 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 because of the snowfall of these things happen. So 6 month this route will stop. So after that we complete this project, the 45 square kilometer area will reduce, and also the this route 6 month connectivity is also started 365 days. So you can see in the wall 1, wall A, and wall C and wall B. In wall A, we have a facing one problem, the sinking of the road. In wall C, because of the sinking of the road, in wall C, we can see the crack is generated. And in the wall B, there was some gaps in the road and the ground level. So these are the problem statements. So these kinds of problems we are facing when we are starting the project. So majorly we work on this particular areas, this certain area. So here's the sinking of road. You can see that the tension cracks is also we observe because of the sinking of the road in hillside and the valley side also. So the direction of subsidence, so it's a hillside road. So because of the hillside, the soil erosion is happening and the sinking is happening. So first, if we not stop this, then we cannot enter in the utter tunnel because of its entrance location. So without protecting this we cannot enter in the tunnel. So you can see that there is Seri Nala also, the continuous flowing Seri Nala. So because of this continuous flowing, the toe erosion is also happening there. So we need to stop this also. So what we done here, we make the RE wall. Here is the avalanche protection we done. The snow fall is, and the we put the barriers also over here. The 3D modeling using drone photogrammetry. We are also working in a photogrammetry project. So we are doing the 3D modeling projects also. You can see the anchor cables before. It's a location of Atal Tunnel. That's before and the after. We the ankle cables we put in the hillside, that the length of this anchor bar is 27 meter to 33 meter. It's vary from 27 meter to 33 meter, and the width of this anchor cables is 3 meter to by 3 meters. Same the same procedure we use the hillside and the valley side also. Cutoff wall we maintain. I told you that there is a Seri Nala. So because of the continuous flowing of Seri Nala, so the soil erosion is happening. So that's why we make this RE wall also. There is the drainage system also. We make the drainage system, that the open drainage catch drain, subscribe drain consisted of PVC pipes, whether non-veg, non-woven. Avalanche barrier. Here you can see the avalanche barrier, which protect the snow. Very large amount of snow if slide from the upside. So here we provide the barriers also. Impact of this project. So majorly we can say that it's this project is only for because the importance of this project is major the connectivity from Manali to from Manali to Lahul split, which reduce the 45 kilometers length, and the 6-month connectivity is also increased above 365 days. So this is the main advantage of this project. Thank you.
Thank you. Now I will call Ms. Chaya to give the memento. Excuse me. Excuse me. Next, we will call Reinforced Art India Private Limited for the speech. Reinforced. I think no one is here, and no, I don't think we have anyone more.
Now there is no more presentation. So we will now break to 3 rooms, LT001, LT002 and LT003 for 3 parallel sessions. So it is schedule is given. So I request all to move to their respective rooms. Thank you.
Yes. Yay, that's really Okay. What are expert? Now we can start my lecture over here. Playlist and there are different sessions. Every session. The number of points, the maximum number of points. So I think that the maximum is to have evaluate. Yes. With you. गाड़ी लाना पड़ेगा गाड़ी फोटो खींचना आप पीछे में फोटो बनवा के लगाना पड़ता है हाँ तो कितना दूर में हमें आगे पीछे फोटो खींचना है जिसमें रहता है उसका अक्षर इसमें पेंसिल से हाँ पटना का पटना का चाहिए जमा मतलब ना ना पोल्यूशन इसलिए चौबीस पाँच साल के लिए 5 साल के लिए ट्रांसफर ऐसी कमी हो पहले उसका करना पड़ेगा 24 फरवरी को कहाँ से समय कहाँ है तो सब पेपर जमा होता है पहले पार्टी उसका 5 साल के लिए बढ़ेगा उसके बाद ही उसका नहीं गाड़ी 24
5 फीट के तो भैया
डेस्कटॉप पे था क्या?
हाँ A2 टेक्निकल सेक्शन इसी फाइल में सबका रजिस्टर सर बोले 13 में कितने आए हैं कुछ मालूम है
सर अभी तो ये 4 अपलोड है।
कौन सा उसमें एक है शायद का थीम एक मेरा है थीम में
हाँ ये तो लास्ट वाला रिटेनिंग
पेपर
स्ट्रक्चर
आईडी 102 है
पेपर
पेपर आईडी 102 और रिटेनिंग स्ट्रक्चर
तुमने देख ओपन करो ना उसको कंपनी का तो हो
के बाद रिकवरी का है
ओके
दैट इज ऑन अनदर थीम लिखते हैं
क्या नाम है उसका क्या नाम है देखो
मोस्ट वाला है सर
तो मैकाफेरी
सौरभ राजपूत
सौरभ राजपूत कौन सा लेगा और फर्स्ट पेपर किस Mani Mahesh, Professor R.K. Srivastava. Amendment of expensive soil.
Yeah, no.
ये 155 ना? हाँ.
सर एक फाइल बना उसमें
उसी में रख दो क्या मैं डेट 2 हाँ इसीलिए
155.
पानी का बोतल 2-3 रख दो.
Yes.
जी.
Yes.
सर मनी एनआईटी राउरकेला रवि सर कहते आपण हेतु
अच्छा रवि सर
वकील एनआईटी
किसका स्टूडेंट है तो
सर
सुनील खटो का
खुंटिया सर
कौनटिया का ना? अच्छा
Right,
अच्छा. कब आया?
सर मैं 21 को ही मतलब 18 को ही आ गया था.
अच्छा अच्छा.
हाँ
तो कैसा लग रहा है?
अच्छा है सर. अच्छा
ठीक है.
arrangement है. हाँ
डिपार्टमेंट गया था, लैपटॉप घुमा.
हाँ
नहीं,
सर,
अभी
कल का प्लान है.
लोगों का
अभी
कॉपी
आज पेपर है वो खत्म हो जाए ये
4-5
प्रेजेंटेशन.
लोगों का बचा है, अभी 4 बचे हुए हैं उनका
संबित
कॉपी
कर
करना है बस.
तो तुम भी उड़ीसा से?
आगे आगे आगे
कहाँ से है?
उड़ीसा भुवनेश्वर सर का है.
अच्छा अच्छा. मैं तो अभी राउरकेला गया था क्रिसमस के दिन.
अच्छा
बढ़िया से दीजिए.
हमने तो अभी में देखा था. और सर को बुलाने आने के लिए उसके बाद क्या करेंगे?
और लोग जरा तो नहीं
हाँ स्टूडेंट लोग तो सब लोग जानते हैं.
Let's wait people.
ठीक है. तो आज
एक है मेरा पेपर 53
53 और
दूसरा ये आईसीड 224 पटना और एक पेपर 58 शुभेंदु
ये शुभेंदु
और ये 3. हाँ
ओ सॉरी ये
नहीं ऊपर से 3
ऊपर से 3
ये नीचे वाला नहीं.
ठीक.
अभी तो ये 1 साल हुआ है. ये पहले आईआईटी बीएससी करता था.
सही सही आएगा.
हाँ देख सकते हैं.
ऊपर वाला
ठीक है.
53 तीसरा देखिए आईसीड 222
आपका शौकीन.
Do you know where she was? Here.
1 मिनट. ओ फाइल भी कटा हुआ है.
ज़्यादा लोग रहता नहीं है. Yeah, on the books is again on some writing. Oh yes. University of Science and Technology. Yes.
डे 2 टेक्निकल यही था शायद ना. हाँ
I have to find
नहीं मेरा पीएचडी कंप्लीट हो गया है. नहीं लखनऊ यूनिवर्सिटी से.
name, Polish name of this university in English.
Google Translate. So ready to start?
एक ये 155 और एक ये ICEID ये है।
नेक्स्ट पेज में कार्तिकेय सिंह, ठीक है,
और एक ये 155
हो गया,
हो गया।
12 लिख लिया,
ठीक है। शुभेंदु सिंह 58
लिख लिया, 1 2 3 4 5 6
ये
502 लिख लिया, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 8, ठीक है, ऑनलाइन भी है, ठीक बताएंगे।
यहाँ पे स्टार्ट करते हैं।
Okay, good afternoon to all. Am I audible? So, very good afternoon. I am Dr. Ramkrishna Bag, so Associate Professor in the Department of Civil and Environmental Engineering, and I am working in the Geotechnical Engineering group. So, I welcome all of you for this technical session 6, which is on retaining structure, ground improvement technique, and contaminant remediation. So the session will be chaired by Professor Krzysztof Starnik from Silesian University of Technology, Poland. And the co-chair is Dr. Nikhil Siddesai from VNIT Nagpur. In this, there are 2 theme lectures will be delivered by Dr. Arvind Jha, who is the co-organizer of this conference, and also another by industry partner by McAfee, Mr. Saurabh Rajput. Followed by there are 13 number of presentations, but so far we have received 6 numbers. Maybe some of them will be online as well. So I hope this will be an interesting session for all of you. With this, I leave the session to the chair, Professor Krzysztof.
Yes.
The last one. Thank you very much. काम कर रहा है ना? Yeah, so first we are going to have 2 theme lectures, and the first one will be given by Dr. Arvind Jha. Please, the floor is yours.
Yeah, thank you very much. So good afternoon to all of you. So this technical session is basically related to the ground improvement and the ground contamination. So I have selected the topic related to that only. So my topic is the ground contamination of the soil due to sulfate and its consequences on the stabilized soil. So I will just briefly highlight some of the basics behind the ground contamination and what are the different ground improvement techniques. So as we know, the expansive soil is the problematic soil. It creates the problem due to the expansion and the contraction depending upon the moisture and the temporal variation. Okay, so that causes the once it is it comes into the contact with the water, it will swell highly, and then you can see that upon the drying state, it will huge crack will form. So that causes the damage of the building, basically the lightweight building. So what are the mechanism behind the expansion is basically it contains the smectite group of the mineral, that is the montmorillonite, which is highly expansive mineral. So that causes the expansion, that causes the expansion into the soil. So basically, if you understand the physiochemical mechanism behind the expansion, because your clay is negatively charged particle and it has the, like, you can see the clay is like the flat shape. So n number of the water, because your water is the dipolar substances, it has the positive and the negative ion. So you can see in the figure, n number of the, like, water molecule can enter into the flat surface, that causes the expansivity into the soil. There are several factors also, like moisture fluctuation, dry density, amount and the type of the clay minerals, surcharge pressure, that, like, controls the, or that can affect the expansive like, swelling percentage into the soil. So other phenomenon of this, like, you can see the, if the montmorillonite, you have the different group of the mineral, montmorillonite, kaolinite and the illite. Basically montmorillonite has the higher specific surface area, that is 800 meter square per gram. So that means, like, it can contains, it has the huge amount of the surface area or larger surface area that can absorb huge amount of the water. So like, for example, if you have the 10 gram of the clay, montmorillonite clay, you can spread all over the football ground. So that is the, like, larger area it has. So that's why the swelling or expansion on this type of the particular soil is high, and that causes the problem into the structure. So if we have the, like, this type of the problematic soil, how to encounter this problem? So basically we are, like, using some of the terminology like the ground treatment. That is nothing but the process, what process you are going to adopt. Okay, and then ground improvement, that is the purpose of the, what is your purpose basically, either you want to improve the strength or the permeability or what properties. Then finally the ground stabilization and the ground modification, that is the result, what you are going to achieve, desired result. So there are several ground improvement technique that has been, like, this is the basic thing that we all understand. So there are several classification of the ground techniques. So I will be discussing basically particularly about the mechanical modification of the, chemical modification of the soil. So, but while using the chemical stabilization of the soil, you have to have, like, basic understanding about some of the, like, ideas that you have to think. Otherwise, like, it creates the problem as well. It will give your adverse effect rather than the, like, positive impact. So one thing basically you have to understand is the desired result. Which things you want to improve? Desired result means the properties basically, like either the engineering property, strength, permeability or the settlement, whatever desired result you want to achieve, that you have to have the clear idea. Then other is the type of the soil and the characteristic. Okay, like which type of the soil is there? What is the basic characteristic of this one? Not only basic, but the chemical characteristic of the soil is very important when you are going for the chemical stabilization. Okay, so characteristic is very important, but like diagnosis of the, like, soil basically. Then clear understanding about the use of the additives that you are going to use, either lime, cement or whatever pozzolanic material you are going to use. You have to have clear idea about what is the interaction mechanism between these two are there, and what will be the, like, how it will react, and what will be the end result. Understanding of and the means of the incorporating the mixing additive. If you are not mixing properly, you cannot achieve, like, the uniform improvement into the ground. And finally, like, the understanding how the resulting engineered soil will perform. That is nothing but the durability or the longevity potential of the soil, treated soil. So I will tell you, like, this. I will tell you, like, the strong basis of the why characterization is required. Okay, because our soil is basically three-phase diagram. This is the basic soil mechanics. So like, it contains the solid and the voids. So if you have the solid, it may contains the clay or the sand or the silt. If you have the sand and the silt, it will create less problem. But when you are dealing with the clay, it has the huge problem. Because why I am saying huge problem? Because clay may contains, like, different type of the mineral. There are n number of the minerals are there. Okay, so you have to understand about these type of the minerals, and once these mineral will come into the contact with the water, okay, because each mineral has their own properties, either a smectite group of the mineral or the mica or the kaolin. Okay, it results differently. Okay, so now if these type of the minerals come into the contact with any contaminated water or other type of the liquid like the acid or the base, then you can see the complexity in the interaction mechanism between these mineral and their consequences on the the final outcome, that is the what properties that you want to achieve. So dealing with the clay is very difficult, even difficult when the ground will contaminate with the different type of the liquid. So like that's why understanding of the clay mineralogy is very important, and also this is the one of the good finding basically. That's why I kept here. You can see this is the CV is nothing but the consolidation coefficient of consolidation, and you can see this. I'll just give you the two example of this is the sodium montmorillonite, this is the calcium montmorillonite. Both are montmorillonite, but their cations are different, sodium and one is calcium. Now you can see the variation in the result, difference in the result of the coefficient of consolidation. So not only the montmorillonite, what exactly the cations they are adopting. So now you can see the complexity in the understanding on the clay mineralogy. So that will causes the huge difference in the outcomes. So and in environment we are dealing with the different kind of the things, like you have the temperature variation, you have the moisture variation, there are alkali, acid, ground contamination. So interaction mechanism will be more complex. So what are the basically this lime stabilization has been used earlier, and it is the proven proven stabilization technique. See, there is the lime association, National Lime Association is there. They have already this published the protocol also. So it is proven techniques to stabilize the soil, okay, and to improve the properties of the soil. So there are different applications you can see in the figure, in the road, airport, or the embankment, and different type of the limes are being used. Either it is calcium oxide, calcium hydroxide, and the calcium carbonate. What are the mechanisms behind the lime stabilization? There are two mechanisms. One is the short-term reaction, other is the long-term reaction. Basically, short-term reaction will give you the modification of the soil. Okay, so modification means either the physical property, like the consistency limit, okay, that will improved by the short-term reaction. So there are two type of the short-term reaction. One is the cation exchange, and the flocculation will be there with the consequences of the cation exchange. So cation exchange is nothing but basically the exchange of the ions, because your montmorillonite contains your clay contains the sodium. Sodium is the monovalent ion, and once you are adding the lime contains the calcium. Calcium is the divalent ion. So lower valency can be replaced by the higher valent ion. So that is the the cation exchange mechanism, and that causes the flocculation. Like if your particle is dispersed, it will be flocculated structure. So that causes the change in the modification of the soil. So generally 1 to 3% lime is sufficient, depending upon the type of the soil. It is sufficient to modify the soil. But and other is the carbonation reaction. When temperature you are using the lime in the highly where temperature is high. In that case, there will be the formation of the calcium carbonate. Basically, sometimes it causes the reduction in the it will give you the reduction in the strength, or there is less effect, marginal effect due to this one. The main is the pozzolanic reaction, that is called as the long-term reaction. So basically in this reaction, what will happen? The calcium will react with the silica and the alumina. That is silica soil is basic montmorillonite or whatever mineral is there, that is aluminosilicate mineral. So it will react with the calcium in the presence of the moisture or the water. That causes the formation of the cementitious gel, either calcium silicate hydrate or the calcium aluminate hydrate. Okay, so this dash you can see, because this is very complex outcome, and identification of those CSH and the CAH depends upon the several factors. Okay, so generally 2 to 8% lime is is required for the soil stabilization. Pozzolanic reaction, it will take time. Okay, that's why you can you may aware with the we have to cure the sample for the 28 day or 14 day or more than 28 day, because this reaction will take time. It will not. So, but short term reaction, immediately it will start. So this pozzolanic reaction basically depends upon the the several factors, like the pH, solubility of the silica and the alumina, clay mineralogy, and the curing condition. So that's why understanding of the chemistry involved and their effect is very important when you are going for the chemical stabilization. So now the things is there are several example you can find, or the several projects has been damaged which was stabilized by the chemical stabilization, or either it is lime or the cement. So that actually basically that basically causes the questioning the validity of the calcium based stabilization. Many in the USA or Iran, wherever you can find some paper or the reports, lime stabilization was done, but after some time it was damaged, huge swell or the heaving was done. So it now the question is either lime stabilization or the chemical based stabilization is valid for all type of the soil or not. That is the major question. So if you have the ground is contaminated with the acid, alkali, salt or the sulfate, what is the consequences, or the seasonal variation is there? Okay, so what is the consequences are there if you are going for the lime stabilization? So here I will be discussing about the sulfate bearing soil. Basically sulfate bearing is the soil which contains basically more than 2000 ppm sulfate. So that type of the soil is called as the sulfate bearing soil. Okay, so basically it is reported that the 20% of the land in the throughout the world is covered with the sulfate, any type of the sulfate into the soil. So in India it is 0.06%. So basically there are two type of the sulfate bearing soil. One is if the soil is present in the natural state, and other is if there are contamination of the ground due to some other sources. So in both cases it will be it will causes the problem when you are going for the sulfate calcium based stabilization. So there are two type of the sources. One is the primary source, other are the secondary source. Primary source is basically there are direct presence of the sulfate bearing mineral like the gypsum, sodium sulfate, potassium sulfate or the magnesium sulfate. Secondary sources are basically when you are it is basically happens when near to the mining industries, because there are huge amount of the alkaline water will discharge that will react with the sulfuric acid that is produced from the oxidation of the pyrite, that results that causes the introduction of the gypsum. Gypsum is the type of the sulfate into the soil. So that is called as the indirect source of the soil. So gypsum is basically it has the low solubility compared to other type of the sulfating mineral. That's why the most of the soil gypsum are present compared to other type of the sulfate. So there are various case studies has been reported related to the ground contamination, and all has basically shown the there are adverse effect. Okay, so effect how it what is the mechanism behind the sulfate and the calcium based stabilization? So let's see here you have the expansive soil and you are going for the lime treatment. Okay, and then after some time there will be the contamination of the sulfate due to the groundwater or any environmental nearby sources. So then it will cause the sulfate induced heave into the soil. And other problem is basically this is the sulfate, you have sulfate is there into the nature, into the natural soil, and then without characterizing the soil, if you go for the lime treatment, that also causes the sulfate, but the result between result of the both will be different. Okay, one is later sulfate is contaminated, and other is sulfate is there, you are going for the lime treatment. So why the sulfate induced heave occur? Basically this is due to the formation of the Icgeid mineral or the thaumasite mineral depending upon the temperature. If temperature is greater than 15 degree, Icgeid will mineral will occur, because Icgeid is the highly swelling mineral. It swell up to 137%. Okay, so and there are complex reaction. I have written in one line, but if it is in, you can write in if you see the literature, it is written in 1-2 page. Okay, there are series of the reaction will occur, and then finally there will be the formation of the Icgeid. So basically it is the reaction between calcium that is liberated from the lime and the alumina that is released from the clay, and the presence of the hydroxyl ion that is OH that is from the lime, and the sulfate mineral that is SO4, and in the presence of the water there will be the formation of the Icgeid. So you can see this is the microscopic view of the Icgeid, which is formed in the, over the you can see that this is the fly ash particle. This is, if you see the microscopic view, it looks like the flower, like the Icgeid crystal particle. So okay, so the formation of the Icgeid basically causes the huge heave. That's why it is termed as the sulfate induced heave or sulfate attack or the man-made expansion, because you are not going to characterize the soil initially and you go for the chemical stabilization. That's why it is called as the man-made expansion as well. So this is the complex structure of the Icgeid mineral. I will not go into the details of this one. And there are two mechanisms of the expansion. One is the crystal growth theory, other is the hydration theory. Basically, this is the contradiction between the literature. So crystal growth theory says long-term effect will be not there. Okay. So crystal growth theory says the effects only to the long-term pozzolanic reaction, means the formation of the heave or the swell will occurs at the longer time period, after longer time period. But the hydration theory says no, once there is everything will be there, like calcium sulfate in the presence of the water, immediately swell will occur. So these are the contradiction between this one. So we have tried to look into these aspects. So I will discuss about here the first case where the presence of the sulfate mineral is there into the natural soil. And if you go for the lime treatment, so this is the black cotton soil we have taken, that is called as the expansive soil, and these are the properties of the soil which contains the montmorillonite, silica and the aluminum sulfate as well. So characterization is very important. That's why we have done the SCM analysis of all the chemicals that has been used. This is sulfate. You can see the flake like this one, and then the lime are there. So and the EDEX has been done. That is the chemical composition, elemental composition you can get, and you can see the alumina and the silica ratio is 1:2 approximately. So it confirms that there are the presence of the montmorillonite, because montmorillonite is called as the 2:1 mineral. Okay. So now you can see the result. What happens basically, we have treated the soil with the 6% lime. 6% lime is basically the optimum lime for this soil. We have obtained this content from the pH test. Okay, and then we have tried to try to introduce the sulfate into the soil by using the gypsum basically. So there are different type of the gypsum we have used, and we have examined the swelling behavior of the soil. So once we are treating the soil with the lime, there is no swell. Swell is completely eliminated into the expansive soil. Once there are the presence of the sulfate into the soil, you can see this drastically increase in the swell, and this swell is increasing with the percentage of the soil. But other things we have observed, that once we treat the soil with the lime and we kept for the swelling, and then after the curing period, once the soil is cured for the 28 day or the 7 day or the 14 day, the swelling is basically reducing. Okay. So from this analysis, we have confirmed that there are immediate swelling will occur into the soil once you are going for the sulfate and the lime treatment. Okay. And and this is the SCM image. You can see we have taken for the different soil sample, the same soil sample which was tested for the swelling behavior. So now you can see, I will just show you. You can see this 6% lime, 2% gypsum. You can see this is the Icgeid particle. You can see 0 means there is no curing basically. So the size of the particle you can see here, and similarly you can see for the 0-day curing period, the size of the Icgeid is huge. So that causes the excessive swelling into the soil immediately. Okay, but once there are the sample is cured for the different period, you can see there are the formation of the Icgeid is less. Basically, once it will go for the curing, cementitious compound will dominate the formation of the Icgeid particle. So that's why you can see the swelling is not there. So then after doing the several things, we have come up with the hypothesis there are the without curing and the with curing. Initially, these are the soil particle. You have the void into the soil particle. Once there are moisture will be there, it all the ions will migrate into the voids. And if you go for the without curing, you can see there will be the nucleation of the Icgeid particle, and up to this level there will be no swelling. Once it will again grow, then it will push the particle apart and then swelling will occur. So that's why up to this period is called as the nucleation period, and after that it is called as the growth period. But when the sample is cured for the different curing period, you can see there will be the formation of the cementitious gel that binds the particle, and the growth of the Icgeid is less. It cannot, because the binding of the particle make the stronger. Even Icgeid cannot push. So that's why you can see the swelling is less. So now influence of the metal sulfate, basically whatever I shown you, that is by using the gypsum. So later, like now we have done for the different metal sulfate, either it is gypsum, sodium sulfate, magnesium sulfate, or the calcium sulfate. All are the sulfate only. You can see in all this one you can have the SO4, 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 but only difference is the cations. In gypsum, calcium is there. In sodium sulfate, sodium, magnesium, and the potassium. So one group is divalent cation, other group is the monovalent cation. So that causes the difference in the result. So this is like and that you can understand by what is the effect of the different cations. This is the lyotropic series. Basically, it will give you the idea about how the ion can exchange with each other. Basically, higher valency can exchange with the higher valency can replace the lower valency ion. So then these are the properties of the soil that we have used basically for the findings. So these are the different set of the experiment that we have done for the different by using the different metal sulfate with the different percentage, so that we can simulate with the ground condition if the sulfate at different levels are there, then what will be the consequences on this one. So now you can see the plasticity index with the metal sulfate. You can see the variation in the result. Okay, if the sodium is giving the highest plasticity, because the sodium is can increase the this hydration rate will be high for the sodium compared to the other type of the divalent compound.
Please finish.
Yeah, I'll just go quickly. So then you can see I'll just show you one slide and then I will stop. Yeah, so this is the maximum solid percentage. This is very interesting result basically. All are the sulfate treated with the lime, but sodium sulfate is giving the higher maximum swelling percentage, because and the potassium, because sodium and the potassium are the larger hydrosphere compared to these two minerals. So this is the it's not only the sulfate, which type of the sulfate is there, what is the cations are there, and then how it is reacting. So all depends. So we have done for the different mellowing period to reduce, either sulfate can be reduced. So mellowing period controls little bit with the sulfate effect. So basically the summary of this one is, when you are going for the chemical stabilization, you have to characterize the soil in details, and then only you can use the chemical stabilization. Otherwise it causes the adverse effect as well. So I'll just, because you came from the different part of the country, so we have the excellent geotechnical facility, laboratory facility in our department. So you can visit sometime into the laboratory. So we have the all the testing facility. You can geophysical and the physical testing facility, soil dynamics facility, ground improvement facilities are there. Okay, and then we have established the biogeotechnical and geoenvironmental engineering laboratory. We have the rock engineering testing facilities as well. Okay, and there are several computational facilities we have in our laboratory. Okay, so we have almost all software, whatever sophisticated software is there, we have in the laboratory. Okay, so and these are some of the highlights of this. We are currently working on this one in the biogeotechnical area. Okay, and these are the process. Okay, some of the research we are doing in the rock bolt pulling test and the analysis, stability analysis of the different slopes. These are the project which is going in our laboratory. So we have the group of geotechnical faculty, those who are working we are working together in our laboratory. So you can visit sometime, you have some time and visit our laboratory. Okay, thank you very much. I took a little bit more time, so sorry for that.
Thank you very much. And there is the second theme lecture, which will be given by Mr. Arvind from McAfee Company. Yes, please.
retaining structure.
And please try to fit within 10 minutes, maybe, okay?
My name is Saurav Rajput. Mr. Arvind was not able to come, so I am presenting on behalf of him. Hello? So yeah, my name is Saurav Rajput. I am working in McAfee as a senior manager, and topic of my presentation is retaining structure and ground improvement technique. So flow of my presentation will be, first we will, I have 2 slides of introduction for each type of solution. Then we will see what are the retaining structures, what are the different type of retaining structure, and then case studies of those retaining structures. Then similar with the ground improvement, and then case study of the ground improvement. So what are the different type of problems which generally happens in the case of slope? First is that slope stability analysis, that sometimes general shear failure, general stability failure and deep seated failures has happened in the case of slopes. And if we cut the slope and if we cut the toe of the slope, that slope become unstable. And sometimes if you want to raise the height of the embankment, and if you want to do the extension of the slope, so all these problems can be taken care by the retaining structures. And the conventional, in the conventional retaining structures like RCC wall, these are some advanced retaining structures which are called reinforced soil structures. Then what are the different typical problems happens in the case of in situ soil? This in situ soil, if that is not if soil is soft or very loose, in those cases this bearing capacity failure and immediate and consolidation settlement failures has happened. And stability also has happened in the case of loose soil, and liquefaction happens in the case of loose sand. So all these problems can be taken care by the ground improvement. So first start with the retaining structure. What is retaining structure? As I told you that RCC is the conventional retaining structure, and these reinforced soil structure are the advanced structures. And what is reinforced soil structure? Reinforced soil structure is a composite mass of soil, reinforcement and fascia. So, and these composite mass formed by the friction between the soil and the reinforcement. So as per guideline, if your face of the reinforced soil structure is greater than 70 degree, we call it as a reinforced soil wall. And if angle is less than 70 degree or equal to 70 degree, we call it as a reinforced soil slope. And the fascia of this reinforced soil wall and slope could be Gabbian fascia, concrete fascia and green fascia. So in the case of Gabbian fascia, these are the Gabbian fascia which are filled with the stone, and it has integrated tail of 3 meter length. These tails act as a primary reinforcement in the case of lower height like 3 to 4 meter, and if your height is more than 3 to 4 meter, in those cases these tail act as a secondary reinforcement and geogrid act as a primary reinforcement. So geogrid placed between these Gabbian boxes, and this composite mass act as a reinforced soil structure. Then similar with the green fascia, in the green fascia, the fascia is welded wire mesh along with the double twisted wire mesh. It also has a integrated tail of 3 meter, which acts as a primary reinforcement in lower height, and for greater height, geogrid is the reinforcement. And these reinforced soil structure could also be a combination of green fascia and Gabbian fascia. Either by bottom is Gabbian fascia and top is green fascia, or side by side. So these reinforced soil structure also classified based on the different type of fascia. If there is no fascia like welded wire mesh or Gabbian fascia or green fascia, and if the reinforcement geogrid itself wrap onto the soil, we call it as a soft fascia, and it also called as a wraparound system. Then stone fascia, Gabbian fascia, green fascia, I already discussed in the previous slides. Then in the case of concrete fascia, there are 2 types of fascia, could be given like modular blocks and concrete panels. Concrete panels walls you already must have seen in all the highways. Now all the flyovers approaches are built by this technology. So these are the reinforcement which are used in the case of reinforced soil structure. It could be geosynthetic material or metallic strips. In the case of geosynthetic, polymeric strips is the one of the option, and geogrids are the another option. And these geogrids are based on the two different type of material, polyester based and HDPE based. Then in the case of metallic strip, plain smooth strip could be given, high endurance strip could be given, and DT mesh, which I already told you that these integrated tail act as a primary reinforcement in case of lower heights. So what is the basic principle of reinforced soil? We all know that soil is weak in tension and good in compression. So to add a reinforcing material, by adding a reinforcing material, we actually transferring the tensile strength into the reinforcement. By this, we can build a reinforced soil structure. So what are the different steps involved in the case of design and analysis of reinforced soil structure? Similar like any gravity structure, any retaining structure, external stability checks are there. This complete reinforced soil block act as a single block, and the soil behind this reinforced block apply pressure on this wall, and all this wall is checked for all these external stability checks like sliding check, overturning, bearing, and settlement. Then internal stability is also a important part of the design of reinforced soil structure. The reinforcement, these reinforcements are checked for the rupture and pull out. Then global stability analysis is slip circle analysis, and these are the software. This is a software output MacStar, which we are using to analyze these reinforced soil structures. Then other than reinforced soil structure, gravity gabion can also act as a retaining structure, and these gravity gabion boxes are filled with the stone and placed one onto the other to make a gravity gabion structure. These are the codal references for the reinforced soil structure: IRC-SP 102, BS 8006, and FSW NHI 024. These three guidelines for the design of reinforced soil wall. Then BS 8006 and NHI 025 is for the design guideline of the reinforced soil slope. Then IRC-SP 116 is the design guideline for gabion structure. So what are the different application of reinforced soil structure? We all must have seen this type of structure in the highway or railway, but other than highway and railway, mining sectors and landfill sectors, this technology can be useful in the mining and landfill sectors. If you want to increase the capacity of the overburden in the case of mining, in those cases you can build these reinforced structures, reinforced soil structure, to increase the capacity of the overburden dump. Then this is a case study of a reinforced soil structure which we have done in the Jammu, in the state of Jammu, for Srinagar Baramulla rail link road, where the owner is Konkan Rail KRCL, Konkan Rail Corporation Limited, and the proof consultant was IIT Madras. And this is a 55 to 60 meter high reinforced soil structure. So this is one more case study where gravity gabion was proposed to retain the slope. Then this is one more project where this 30 meter high reinforced soil structure was given for the approaches. Then this is also a structure, reinforced soil structure, which we built in the Kalipani chromite mines to increase the capacity of overburden dump and to stabilize the slope. And let's move to the ground improvement. What is ground improvement? Ground improvement is the process of improving the geotechnical properties of the in situ soil. In the case of sand or non-cohesive soil, we can compact the soil, but in the case of clay, we cannot compact the soil, and in those cases, consolidation is the process. So these are the conventional method, some conventional method of ground improvement. First is the removal and replacement. You can remove the loose soil and replace it with the good earth. Then stage construction. You can build your structure in stage wise and allow the soil to settle. Then temporary preloading, in the case where you want to build a RCC structure, in those cases you cannot build your structure directly onto the soft ground. In those cases you can do preloading with the embankment, then allow the soil to settle, and once it settles you remove the preloading and you can build your main structure. Then piled embankment, in case where you don't have time to allow this preloading, in those cases you can build, you can drive the piles and you can build your structure onto the piles. Then sand columns or stone columns. So what are the different advanced solutions? First is basal reinforcement. You can add basal reinforcement in the removal and replacement. Then prefabricated vertical drains to accelerate the consolidation process. Then piled basal reinforcement with pile, and geosynthetic encased stone column. In the case of very loose or very soft soil, like N values ranging from 0 to 2, in those cases if you build your stone column, if you drive your stone column, then stone get mixed into the soil. So in those cases you can encase the stone column with the geosynthetic and you can build the geosynthetic encased column. These are the guidelines for the different type of solutions, different type of ground improvement technique which can be given in different type of soils. Like in the case of sand, shallow compaction, dynamic compaction, vibro compaction, this compaction can be done. And in the case of clay, this PVD stone column and stage construction temporary loading can be given. So by using geosynthetic, that basal, in the case of basal reinforcement, is paragrid and paralink can be used as a basal reinforcement, where if your strength requirement is less than 200 kilonewton, we can use paragrid, and if strength requirement is more than 200 kilonewton, so this paralink can be used. This has strength up to 1600 kilonewton. Then PVD, that prefabricated vertical drain can also, which I already told you, so I am skipping this slide. And then again, this is a geosynthetic encased column. Then this is a case study for which, for a basal reinforcement project which we have done in Barasat to Krishnanagar. Here the problem was that water table was very high, it's up to the ground level. So just to reduce the settlement, we just replace, and to minimize the differential settlement, we use basal reinforcement. This is a typical that solution drawing. Then this is a project for prefabricated vertical drain, which we have done for Kakinada project, where this ROB, this approaches wall was built over the PVD, prefabricated vertical drains. This is a simple, typical drawing where this PVD was installed up to 17.5 or 18 meter high, 18 meter length depth. This is one more project which we have done for railway embankment at Agartala. This is also a PVD project, prefabricated vertical. So we just accelerate the settlement, accelerate the consolidation by using PVD. Then this is a project for stone column which we have done at Mundra, Gujarat, where the stone column were installed below the approaches and then basal reinforcement to minimize the differential settlement. That's it. Thank you. I hope I'm on time.
Thank you very much.
Thank you.
Okay. Let's pass to the main part of the session. We've got only these are present. Six. So we've got 6 presentations, and the first one is titled Amendment of Expansive Soil with Alumina Mine or Waste for Utilization in Earth Structures. And there are 2 authors, Mani Mahesh and Professor R.K. Srivastava, who will be presenting. Mani Mahesh. Yes. Please, 10 minutes, okay?
Hello. 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 Shall I start?
Yes, please. 10 minutes.
Okay. Good afternoon, all of you. I am Mani Mahesh, PhD scholar, United University Prayagraj. I'm doing my research under the guidance of Professor R.K. Srivastava. He's a retired professor from MIT Prayagraj. Today, my topic is amendment of expensive soil with alumina mine waste for utilizing in earth structure. This is my index. Introduction, material and method, sample preparation and testing, methodology, result and discussion and conclusion. Professors have already discussed about a lot of things about the expensive soil, how the expensive soil shrink and swell when it's come to the contact with the water. And we can see how the expensive soil worldwide damaging the structure. A lot of research are already done about it. We can see here around in United States, France, China, South Africa, the structural damage approximately $3,700, etc. Next is the bauxite ore. Bauxite ore is rich in alumina, titanium, and ferric oxide. Lot of study also done on the bauxite ore. My main objective is to convert the expensive soil by utilizing alumina mine ore waste to non-expensive soil by an optimum percentage. Soil was collected in the vicinity of Jabalpur city, and alumina mine waste is collected from the Sagar, Madhya Pradesh, Sagar district, Madhya Pradesh. This is the expensive soil and alumina mine ore waste particle size analysis. This is the general engineering property about the expensive soil. Here we can easily see the liquid limit is 71%, the plastic limit is 31%, and the specific gravity is 2.66. If we see the other geotechnical property also is here. Next, these are the geotechnical properties of the alumina mine ore waste. The specific gravity is 3.33, and the free soil index is only 16%. Liquid limit is 14%. If we add this waste material to the expensive soil in an optimum percent, we can easily improve the strength of the soil. For that purpose, our focus is to prepare the alumina mine weights according to the difference percentage is 8%, 12%, 60%, 20%, 24%, and 28% by weight of expensive soil, and conducted different tests like compaction test, unconfined compressive test, swelling index, all other tests. This is the typical graph of the compaction characteristic of the soil. We can easily see the maximum dye density of the red mud is 1.95, above 1.97, and the black cotton soil is only 1.52. When we add optimum percentage of the alumina mine ore waste in the expensive soil, the strength goes up to 1.67. This is the initial moisture content at the expensive soil is 12%. The UCS test is conducted for 0 hour, 4 hours, 7 days, 14 days, and 28 days. We can, after 7 days, till 7 days, the strength is increased, and then the strength start decreasing because the the alumina, when the water is present in the alumina and the material is ductile, when after the 7 and 14 days, the moisture is just regarded from the sample and it's converted into the brittle material. So the strength firstly increase initial days, after it decrease. Through this table we can easily see here at 7 days strength is higher as compared to 4 hour and 14 days and 20 days, because in this stage the material is ductile. After this the material is converted into brittle. These are the unconfined compressive strength graph for 7 days, and we can easily see the alumina mine ore have a higher strength as compared to expensive soil, and the 20% the value is significantly increased to the initial value at 24%. Next, the UCS graph for the different at the 20% of the different soil. This is the CVR graph for soaked and unsoaked condition, and the alumina mine waste even have a greater strength in unsoaked condition, that is 4.07. Next, the swelling characteristic. We can easily see at 20% the value is minimum, but after 20% the value is again start increasing, and when the value goes till 40%, up to 40% the value is still increasing, after that decreasing. We can easily see here the expensive soil by adding the alumina ore. The result and the swelling property is also changing with different percentage. This is a sinkage limit graph. At 20%, the value is only 17, and sinkage limit of expensive soil or alumina ore weight at a different percentage of OA. ES have 9% sinkage limit and alumina ore has 27.03. At 20%, AO is the shrinkage limit is 16.31, indicate the soil become non-expensive. This is my conclusion. If we add 20% of the alumina mine waste to the expensive soil become non-expensive, and the maximum CVR value for the stabilized soil was found to be 28%. However, a significant change was observed at 20%, where the CVR value increased from 1.14% to 1.35%. The same pattern was observed in the unsoaked CVR value. There, the CVR value increased from 11.86% to 13.72% by adding 25% alumina mine ore waste. The expensive soil began to behave like a non-expensive soil when about 20% alumina mine ore waste was added to it. Thus, mine waste can be significantly utilized to stabilize expensive soil for earth structure, where expensive soil cannot be avoided. Thank you.
Thank you very much for being on time, or before time, actually. And the next presentation, any questions? Any questions? No questions. Thank you very much. Do we have the next presenter online?
पर यहाँ पे 2 आदमी लास्ट प्रेजेंटेशन है 34O आई थिंक ऑनलाइन दिखा हाँ सर ये है ये किए सुंदर देवनाथ एक सब नहीं सिर्फ देव ये तो ज्वाइन तो है ही इनको अलाउ कर
उनको ऑलरेडी ज्वाइंट है
सर ऑलरेडी ज्वाइन है लोग अब शेयर करें उधर से
Okay, so The next presentation is titled Bearing Capacity of Strip Footing on Spatially Random Cohesionless Soils with Eccentric Loading. And there are two authors, Sambit Pani and Dr. Sunil Kuntia, who will be presenting. Welcome, the floor is yours. 10 minutes, please.
Good afternoon, Chair. Good afternoon, Co-Chair. Good afternoon, everyone, audience. My name is Sambit Pani. I'm doing my MTech in under geotechnical specialization under the guidance of Dr. Sunil Kuntia, and I'm going to present to you here my topic: bearing capacity of strip footing on spatially varying random cohesionless soil. So this is my presentation outline. Here we can first go about the introduction and why the need of probabilistic analysis, the purpose and study, and the schematic diagram to understand how actually the soil condition and the basic equation used to establish the study, and the problem domain, parameters used, then results and discussion along with the conclusion. The introduction says that the soil is a function of its depositional characteristics and temporal and spatial variation. So with the advancement of technology and computing powers, now we are capable enough to consider various uncertainties and able to inculcate all kinds of variabilities with respect to time or space, position, and if that we inculcate in our study, and we'll get an optimum result of bearing capacity of footing, so that we can, using that, we can consider our size and shape of the footing, and so that we can also reduce with the shape and our also which in a way optimize our cost benefit ratio. So why the need of probabilistic analysis? Up to the current study, what I found that to understand all kinds of variabilities of soil, it's better to use the probabilistic analysis so that it will till now giving optimum result from the various literature. That's why we can use, and deterministic analysis always gives conservative result, which most of the time overestimates, and sometimes it underestimate the associated risk with the bearing capacity or failure of the structure rather. And comprehensive uncertainties analysis pays up in the long run, and it will increases the longevity of the structure. Though probabilistic analysis is complex, but still we have, due to our computing powers and analytical skill of our computer and computing system, we can consider now to inculcate all kinds of uncertainties. So the purpose of the study to combinedly inculcate the effect of soil variability parameter along with the eccentricities of the footing. So here I have found this from the Spoon and Kulve study. Here taking a soil property with the vertical and how it's fluctuating with respect to the mean, how it's fluctuating with respect to the mean value. This is the scale of deviation, and this is the trend line. That means it's showing the mean value and one soil property, how it's been fluctuating. And with respect to verticality, you can see the scale of fluctuation. This is the methodology that has been used: geometry, then selection of suitable property, validation, input parameters, and for the probabilistic study, and random variable generation, data visualization. And these are some of the stuff that has been used and supportive for this study. And these are formulas that have been used for this study. Here you can see, for making the analysis easy and understandable and relatable, I have considered the unit width of the footing and making it a dimensionless parameter. And this is a reduction factor which has been used in a validation of a study. And this is a probability of failure formula, which can be used to get a broad-based idea of what the study is going to say. And this is a problem domain. Here I have here the boundary condition that when chosen that the domain is so large so that the failure pattern will not be interfering the stress proximity of the footing. And on the top surface, you can see the normal stress and the shear stress is 0. And these are the parameters which has been used. Horizontal correlation length that will be used as a CLX by B. This will also make a dimensionless parameter. And B is the width of the footing, which has been taken a unit width. And vertical correlation length, angle of internal friction, cohesion is kept 0 because cohesion will make the study a bit rigorous. And also I found in a literature that with respect to cohesion, angle of internal friction will have the more variability effect on the bearing capacity. So the coefficient of variation and eccentricity ratio. Here we can say horizontal correlation length, vertical correlation length, and coefficient of variation are the probabilistic variable we will put. It will give varieties of result. Now first, before going to the study, we have done a validation verification of the model. Here the present study have been analyzed with Ganesh et al., which is a computational based study, and these are all experimental studies with their formula and their computational study. This present study is in trend with them. And here we can see here also another validation study established with Sophie et al. And Krishnan Chakravarti, and it is also in following the trend of that. Here both these studies are overestimating the result from the current study because here Sophie et al. Taken the upper bound limit analysis, and Krishnan Chakravarti has taken in different way of considering the covariance. He has actually taken covariance of tan of angle of internal friction, whereas here I have considered the covariance of angle of internal friction directly. Sorry, it is a problem domain with a generated mesh, and with each element at each node, these are some kind of representative image to show different unknowns there in x and y direction normal stresses and shear stresses in the plane. This is to select optimal number of simulation. Although the software manual says 100 to 200 numbers of simulation is okay, but still for the better analysis and optimum result, we have considered 300 numbers of simulation. And here we come to the results what we have obtained. Till now, this is a deterministic study. As we know, with the increase of the eccentricity, the bearing capacity value decreases. But we can see the rate of decrease for the higher phi value is a bit more than the other lower phi values. This is a deterministic study. And here we can see probabilistic study. Here, due to the scale effect, we may not be able to see much variation, but still we can say that for the more covariance value, with respect to deterministic value, the value fluctuates more. It means that more the covariance, more will be the fluctuations with respect to deterministic value. And here we say I have taken a combined effect of vertical correlation length and covariances. So in that we found that with more covariances and less vertical correlation length, the fluctuation is more. That means lesser will be the vertical correlation length, the variation will more. If more will be the covariance, variation will be the more. They're showing an inverse kind of relationship within each other. So this is continuation for 5, 35, 20, and this is for 45. This is 25, 35, 45. This is, we can see here, you can find here for the what I told, that's for the lower vertical correlation length, we can see much more disturbances in the domain, and for higher correlation, vertical correlation lengths, we can see little bit of less disturbance in the domain. Here we can see in the studies also it has been found that with the change in the horizontal correlation length, there is not much more variation. Almost you can see the plots are flat. There not much more variation, and this is due to, it can be understood as a depositional nature, because how the soil has been deposited, it's formed like uniform kind of property will get in the horizontal deposition. And here to know for broader understanding of the sense. We have done a probabilistic analysis. That means we'll get a probability of failure to understand how this functions is getting in a picture in a broader way. So here we can see that actually this is some erratic result we got because at eccentricity 0.5 it is not practically possible, not practically also implementable. Any structure is feasible. So it is just to analyze that is it failing under the failure of soil or footing. But we found that this is failed due to the rotation of excessive rotation of the footing, not the soil. But in other cases, we can see the trend of failure, probability of failure decreasing with the increase of vertical correlation length. Here we can see. And this is for the trend of probability of failure with respect to covariances. And here it's giving the broader understanding of what it is.
1 minute more.
Yeah, sure, sir. This is cumulative distributive function. This is probability density function. Here we can see for the higher correlation length, this is vertical correlation length, and this is probabilistic deterministic value. This is vertical correlation length for 4. This is 0.25. Here we can see more area is coming before the deterministic value, so that it is saying that more will be the vertical correlation length, so the probability of failure will be less because it is tending towards the deterministic value or more than even deterministic value. Here also we are finding the same trend, more areas coverage for lesser vertical correlation length and less area coverage for higher correlation length. And this is a stress proximity, and this is conclusion which I have just explained by showing all the graphs. Thank you, sir.
Thank you very much. But I think that you should have shown us one of the last slides when you passed very quickly, and it was the essential one.
Which one, sir?
Or this one.
Conclusion.
The previous one.
This.
Okay.
This one.
Yes.
This is a stress proximity where you can see this is considered for a particular case phi is equal to 35 degree and for eccentricity is equal to 0. Here we can see how the failure pattern is being followed. Actually, due to mesh refinement, you can see a little bit of disturbance there, but it is following the trend of that Terzaghi bearing capacity failure pattern.
Yes, thank you.
3 zones you can find here, 1 zone, 2nd zone, and 3rd zone, basically.
Okay, thank you.
Thanks, sir.
Any questions? What software did you use?
So actually for basic, most of the studies have been conducted in Optum G2 software. And this is for other studies like mesh generation and correlating other studies, I have used MATLAB.
Okay. Okay. Thank you very much then.
Thanks.
Very nice presentation. Thank you. Okay, so the next presentation, the next talk is titled Bibliometric Review of Future Dynamics of Sustainable Methods in Ground Improvement. There are 2 authors, Ishwar Thapa and Dr. Sufyan Ghani.
Good evening. Good evening.
10 minutes, please. 10 minutes.
Good evening. I am Ishwar Thapa, research scholar from Sarda University. I am guided by Dr. Sufyan Ghani. My title is on bibliometric review on future dynamics of sustainable methods in ground improvement.
Due to increasing urbanization, infrastructure demands a drive adaptation of ground improvement because due to rise in population, the land is limited. Therefore, ground improvement is needed for now. And now the more emphasis in soil mechanics is addressing about the environmental concerns and soil challenges aligning to the global sustainability goals. We all know about the 17 sustainable goals according to the United Nations. And the techniques, these techniques focus on soil property enhancement and foundation stabilizing, preferring the different meeting the infrastructure needs, minimizing environmental impact. Embracing sustainable practice not only supports environmental responsibility, but also presents a compelling business case with lower cost, which we going to find in the relevant literatures, because many research are only laboratory-based research that has been conducted in stabilizing area, because these research about this ground improvement has been started in late 1990s. This previously it is combined with geotechnical engineering from 1990s. It has been little bit divided, and this ground improvement has been studied. Sustainable geotechniques generally prioritize, from the word sustainable, it means that it will make our resources available for the next generation, and it will have the circular economy also. Okay, and these methods mainly focus. Okay, I have developed these 6 pillars of sustainable geotechniques, and mainly on stabilization, biological ground improvement, recycled and alternative materials, geosynthesis and reinforcement, groundwater management, energy efficient techniques, digital and smart technologies. Okay, my process in bibliometric analysis, I have used iOS BOS software. For data acquisition, I have used the Scopus database. Okay, sorry that I haven't put reference over here. This sentence I have taken from a literature. Okay, and Scopus is ideal for the bibliometric. Even I have taken the literatures from January 2000 to April 2023. Okay, this is my research strategy. I have divided the concept into 3 parts: sustainable geotechniques, and these are my keywords. There were 670 documents in sustainable geotechniques. In ground improvement, there are a lot of papers, more than 33,000. And I have done one sustainable geotechniques and ground improvement as a keyword, in which I could find only 9 papers. Okay, these are my citation inside. This figure 1 has shown the minimum of 25 citation with at least 2 publications, in which 108 authors qualify, and A.L. Imran M and Alzuri affiliated with China's Department of Civil and Construction Sustainability were the top authors cited. Okay, this also shows the main patterns of citation, and out of which for the second case, 687 case, this Wayne KMS and Lind EPATL cited with United States and China University of China Academy and Remote Sensing, the most cited author. Okay, this also shows the same patterns for 25. And this figure shows the number of publications for these has increased tremendously over the years. And this figure number 5 also shows the number of publications, which I have divided. This in 2020, we know that due to the COVID, I think I couldn't find the related papers in 2020. Okay. These are the top, in figure number 7 shows the top 8 cited authors, and figure number 7, and figure number 8 also shows the authors with ground improvement. Then these J. Jizong has the top citation, more than 600 citations. Okay, and these were the occurrence of the materials that has been used by the researchers, in which lime and fly ash has been mostly used by the authors. Okay, this analysis highlights the influence of I've already talked about this. Conclusion: this bibliometric review highlights the emphasis of eco-friendly approaches in sustainable development, increasing interdisciplinary collaborations, existing knowledge, and which from this review, it took me more than 3 months to do this. From this, I have found 2 things. Already in first session of this keynote, sir, I've talked about the chemical stabilization, but there is also some gap, because in durability studies, maximum papers they have used the soil samples. Maximum they have used disturbed soil samples, because I haven't found any study that has used the back process undisturbed samples. Their maximum papers They have used the disturbed sample. Undisturbed sample means we can resample the stabilized soil from the field by the undisturbing samples process and retest in the laboratory. To my knowledge, I haven't found any relevant literature which have done the back analysis of those results. Therefore, there needs more in-depth, because after stabilization, in many of the speakers have shown that after stabilization also soil gets failed, because that can be solved by the durability studies only, because we can find a lot of papers in concrete related to durability, and that is not fine. And another is that existing performance evaluation of stabilized soils often consider limited parameters. They have used, you can see that many speakers have taken the soil index parameters only, because there are many, because same clay it will behave different at MSL, and same clay it will behave different at other regions. Therefore, we should take the other different environmental parameters also. And there is a lack of comprehensive optimization framework that emphasizes mechanical economical impairment. I couldn't find a single research that is done on the mechanical economics, that is performance evaluation, because we have seen many industry presentation over here. Everybody has talked about their the products, but nobody has told the benefit cost ratio of the project, because many of these failures occurs in the very least developed country and developing countries. In developed countries, they have got relevant code, standard, everything, they have got protocol, they do. These are the failures are happening in least developed country and underdeveloped countries, many of the failures. Therefore, in those countries, the main problem is crisis of the economy. Therefore, we need to develop the such methods that are economically viable also and with environmental scores also. Therefore, this research should focus more on this. Thank you. Thank you.
Thank you very much. Any questions? We've got time for questions. Please, if you have any.
It's a good presentation. Just a couple of questions. In your PhD, in which stage are you in?
So I am in first year.
First year. So very good work for the first year. I hope that all the students should be doing a thorough review of the keywords as well. It's very good work. Regarding the thing that you said in the last segment, that no one has tested the sample once it has been placed. So there are a couple of works but not purely on civilian journals. They are in mining journals. So you can think of searching for Professor Debashish Deb, IIT Kharagpur, who has stabilized a few soils on the dump, of a mining dump, and they have done the back analysis as well. So you might find some good results there. These are the two.
Thank you.
Okay. So the next paper is titled Bibliometric Review of Residual Shear Strength Estimation in Cohesionless Soils using SPT and CPT. And again, there are two authors, Shubhendu Vikram Singh and Dr. Sufyan Ghani. I think that the first author will be presenting the paper.
Hello, good evening, everyone. Today I'm here to present my topic on bibliometric review of residual shear strength. I'm being guided by Dr. Sufyan Ghani on this topic. So we start. The term residual shear strength, it's very rare topic we discuss. As you can see, for what purpose it is used. It's the least strength that have been acquired by the soil after having a liquefaction, and it happens in cohesionless soil. So it's residual shear strength refers to the ability of soil to bear load after being subjected to damage or deformation.
The strength of soil can be affected by various conditions such as earthquakes, landslides, sinkholes. So accurately predicting residual strength, this is the biggest challenge still exists. How to exactly calculate the residual strength. All of the things that come for, like we are talking about the mitigations, all the companies, those have given the presentations, all of them are talking about the mitigation. So what amount of mitigation we have to actually perform on the site that no one talks, so that the cost optimization can be done. Everyone is here to talk about their techniques, their technology, but no one talks about how effectively we can embed them. So this topic can help in that. The goal is to establish an accurate relationship between the given parameters and residual strength through development of multiple regression model. So as computational techniques are being introduced in research in current world, so using AI models, researchers can develop accurate prediction of residual strength, which can help in improving the design and maintenance and safety of soil. These are some flow failures happened in last year's 2015. Is a high profile. It happened in Samarco, Brazil. Next is a high profile failure, 2019, Romandino. These have been told by Olson. These are the previous case before flow failure. This happened after the flow failure. So to analyze, if we already calculate these strength, what is the residual strength of the soil before failure, so we can mitigate. So again, the topic is bibliometric review. So we have done the on VS where we have searched these topics. So what amount of research has been done with the concept, with these terms? The residual shear strength is being have more than 4,288 documents on this. With related to this topic only, SPT and CPT, there are 233 topics, and this estimation of residual strength using SPT and CPT only 4. So this work has been performed by Olsen and Stark, Idris and Boulanger, and Wang and Kama in 2015. They have used the empirical equations, and that to be very specific, they are specific to the certain area only. In India, basically, we haven't performed, as per my knowledge, as per the data, there have been no such empirical equations have been developed. There is no standard procedures to calculate or evaluate residual shear strength. So these are the publications that have been done on this year-wise. From 2021 to 2016 to 2023, there is a large amount of increase in this research. Then number of publications. These are the outcomes of the bibliometric literature review that have been performed using those severe. There have been more than 550 citations for Cornell D. And one more thing, this is when we search for residual shear strength, basically it comes with the other terms also. For cohesionless soil, we used liquefied shear strength. For clay and cohesive soil, we use different terms. So properties drastically change when we talk about sand and we talk about clay. These are the key factors influencing the residual shear. That we can use in the AI, and we can make iterations and we can come up with this better equation. And also, instead of SPT and CPT, and one more thing, laboratory tests cannot be performed as the soil nature changes when you move from 2 or 3 meter or 5 meter, it changes. But the soil sample taken from the lab is very small, so we cannot perform it on the whole area. We have to. So we can come up with a small kind of test or geophysical methods that can analyze and give better analysis of this. These are what is the importance of residual shear strength factors that we can have in India. We can develop some code related to this. This is my scope of study. There is a need of standardized sustainability assessment framework for SPT and CPT projects. Long-term monitoring studies on field performance of sustainable techniques are lacking. There are limited case studies validating reliability and effectiveness of innovative methods. There will be more research focused, especially on Indian context, is needed. Knowledge gaps exist in correlating SPT, CPT results with residual shear strength parameters. Collaboration between geotechnical engineers, like we all are here, we can share some data also for this. Advanced computing and AI can be leveraged to greater extent for analysis and modeling. Conclusions are, I have already talked about. These are the references. Thank you.
Thank you very much. And again, very interesting. Questions, please? Shear strength in SPT and CPT? No questions. Thank you very much.
Thank you, sir.
And the next presentation is titled Application of Montmorillonite nanoclay in improving the behavior of untreated and treated fly ash with lime. Two authors, Ajit Kumar and Arvind Kumar Jha. And presenting Mr. Ajit Kumar.
Yes.
Floor is yours. Please.
Good afternoon, everyone. My name is Ajit Kumar, and I am the research scholar of IIT Patna in the Department of Civil Engineering, and I am currently pursuing PhD under the supervision of Dr. Arvind Kumar Jha sir. So my topic is the application of Montmorillonite nanoclay in improving the engineering behavior of the untreated and lime-treated fly ash. So geotechnical engineers often encounter with the problematic materials. So problematic materials is nothing but the material which is having the inadequate engineering properties. Inadequate engineering property means have the less bearing capacity, more compressivity, and high permeability, etc. And these are the some examples of the problematic material such as fly ash, iron slag, and red mud. These problematic materials are generated from the industry, or it is also called the industry waste. Like fly ash is generated from the coal thermal power plant, and iron slag from the iron industry, and the red mud is from the alumina industries. So this problematic material generated in the very huge amount. So there should be the amendment of this soil is needed. So moving to the material characterization. So here the first one is the in this study I am discussing about the mostly the fly ash. So these are the geotechnical properties of the fly ash, and here the particle size distribution curve of fly ash shows the silty and the fine grain soil is predominant. And now the mineralogical and microstructural analysis of the fly ash, like here the uh, X-ray diffraction pattern shows the peaks of the mullite and the quartz are in predominant, and here the ACM images shows the spherical structure of the fly ash, and the EDX analysis shows the percentage of element present in the fly ash. The another material is the nanoclay. So in the XRD analysis, the peaks of the monolite appears more, and by the ACM images, it shows the platy structure. Here, the platy structure of the nanoclay, and due to its platy structure, it has the high specific surface area. Now come to the methodology sections. So in this present study, uh, the soil combination, material combination in two series. The first series is used with the fly ash with the nanoclay, and in the second series, fly ash, lime, and nanoclay. The percentage of nanoclay varying from 1 and 2%. And the amount of the lime is fixed, and it's 1%, and it is determined from the pH method. Now come to the result and discussion section. So this slide shows the liquid limit behavior and the compaction characteristic of the fly ash in untreated and lime treated. So liquid limit increases with the increase in percentage of nanoclay in both cases, with the untreated condition and the lime treated condition. And in compaction characteristic, the maximum dry unit weight of the lime decreases with the increase in percentage of nanoclay, and in opposite nature is found in the lime treated fly ash. Now moving to the strength behavior section. So in this strength of the untreated fly ash and lime treated fly ash in both cases increases with the increase in percentage of nanoclay. But in untreated condition, the increase in strength due to the improvement in the gradation and induce the cohesiveness between the fly ash and the nanoclay. Whereas in lime treated fly ash, the increase in strength due to the pozzolanic reaction and the formation of cementitious material such as calcium silicate hydrates, calcium aluminate silicate hydrates. Now this slide shows the compressivity behavior of the untreated and lime treated fly ash. So here the initial void ratio of the untreated fly ash increases with the amendment of the nanoclay, and another one with lime treated, the initial void ratio decreases with the increase the percentage of nanoclay. It is due to the increase the denseness of the matrix. Now this is the microstructural and mineral structure analysis, and here this XRD curve is the UCS samples. Like here we can see that the fly ash with nanoclay, there is only mullite and the quartz peak appear, whereas the lime treated fly ash with nanoclay, here the cementitious materials such as calcium silicate hydrates, calcium aluminate silicate hydrates, these peaks are appears. This is the reason. This is the factor. That's why the increase UCS behavior increases. Here the ACM images of the compressivity, and we can see that here the flash with increase nanoclay, it's voids. It creates voids in the matrix, whereas lime treated with the flash, it forms the formation of the cementitious compound like CHS and CAS gels. And these are my conclusions. Like in both cases, untreated and lime treated cases, the liquid limit increases with increasing percentage of nanoclay, and the UCS, the dry unit weight in the untreated fly ash, it decreases, and OMC increases, whereas in lime treated case, the optimum moisture dry unit weight is increases, whereas the optimum moisture content decreases. And the UCS is increases with the addition of 2% nano clay content by 1.77 times than the fly ash, and in lime treated case, the UCS value increases by 1.73 times after the 28 days of curing. And in lime treated fly ash, when we add the 2% of nano clay, its UCS value increased by 1.3 times. Here the compressivity, compressivity with the untreated fly ash, it is decreasing, and with lime treated compressivity increasing. And XRD and ACM images shows that the formation of cementitious compound, and it is also the change the particle arrangement. due to the filling of the nanoclear sand particles, and this is the main reason for the changing the strength and the compressivity behavior. These are the references, and thank you.
Thank you very much. Questions? No? No questions? Then thank you very much.
Thank you, sir.
Very nice. And the next presentation will be titled Comparative Study of Different Methods of Estimation of Liquefaction, and it will be presented by the author, Karthikey Singh.
स्लाइड आगे करने के लिए
Good evening, everyone. I am Karthikeya Singh from L&T Construction, Chennai, and my topic for discussion is comparative studies of different method of estimation of liquefaction. This is the order of my discussion. First introduction, then methods, then soil parameters, steps of analysis, then all four methods discussion, after that LPI, then results and discussion, after conclusion, and then reference. So first liquefaction, as we all know, liquefaction is just reduction of shear strength of the soil. Due to the seismic activity, excess pore pressure generated, which reduces the effect of effective stress, and this causes a significant reduction in the shear strength of the soil, or we can say residual shear strength of the soil. So mainly this area of liquefaction susceptibility depends upon the types of deposits, like it's a alluvial deposit or man-made deposit or wind deposit. Secondly is age of deposit. Older the deposit, less chances of liquefaction. Third is depth of water table. If water table is at the ground level, that area is more prone to the liquefaction. After that, geomorphology mainly means topography of the it is hill terrace or reclaimed land. What kind of land? It depends on liquefaction. Liquefaction depends on that. After that, seismicity. If seismicity is high, there is a more chances of liquefaction in that area. After that, in particular area, what are the parameters in which liquefaction potential depends? It depends on the soil type, like it's a kind of silty sand, alta, or sand. Secondly, properties of the soil, unit weight, liquid limit, plastic limit, and fineness, all these things. After that, SPT values. Now, to estimate liquefaction, various methods are there. First are laboratory methods like 1G shaking table test, cyclic shear test, dynamic triaxial test. Secondly, numerical modeling using software like Plexis or Flag, we can use model the liquefaction. After that, empirical methods and using in situ and laboratory test methods. My study is based on the third, in which I used SPT based four methods I use and give the comparative studies. All four methods are 1893 2016, IS code 1893 2016. Second is China GB 511 2010. Third is Bollinger-Andrews method 2014, and fourth is Japanese bridge method, or we can say Iwasaki 1971 method, extension of Iwasaki 1971 method. This is a Japanese bridge method. And for this, I used earthquake magnitude of 6.9, having 0.24 PGA value, and second comparison is for 7.5 magnitude of earthquake and 0.36 G of PGA value. These are the soil parameters I used. This is basically in Patna region. From here, first is a Vidyut Bhavan station, 10 soil parameters, in which SPT ranges for initially 7.5 meter, depth is 5 to 10. Second is 18 to 49, and third is 30 to 59. Second is Majhiavan, which is 130 kilometer from this Patna city. The SPT values at that region is 12 to 51, and then 37 to 21 for next 15 to 30 meter, and after that refusal values are getting. Third is Digha Thana. This new bridge is constructing in Patna. This is JP Setu. This where the SPT values is found to be 6 to 34, initially 18 meter, after that 28 to refusal values. Third is Dighawara region, which is 40 kilometer from the Patna region, where the SPT values for initially 0 to 9 meter is very less, 4 to 15 meter only. After that 17 to 40 for next 9 up to 22.5 meter depth. After that 45 to 69, and then 58 to 77. As we know, Bihar Patna falls under the seismic zone of 4. So I selected values based on seismic zone 4 as per code IS 1893/2016. This is the analysis order. I skip. Now first, this is the order. This is the calculations for which I used. First is cyclic stress ratio. CSR value is just a predicted value for any soil. So it is 0.65 A max upon G, sigma B upon sigma dash B into RD. In this is basically a shear strength of the soil, predicted shear strength of the soil, and here 0.65 we multiplied 0.65 because in 1971 Seed and Idris told that for tau average we should use that is 65% of the tau max value. So here they had in this code also they use 0.65 meter 0.65 as a reduction as a value, constant value, and RD is calculating by using this method. Now second is CRR. CRR is basically one empirical relation they had given in IS code. This is the equation. For this CIR, N160 CS is the parameter mainly we have to find out, and for these parameters we have these kinds of calculations. First we have to calculate from field SPT value. We find N60 using all corrections. After that N60 we use overburden correction and we get N160. After using this N160 we have one equation alpha plus beta N160, from which we get N160 CS, and by using N160 CS we have to calculate CRR. But all these equations had given for magnitude of 7.5 Richter scale. So if we have some other magnitude, like I use 6.9, we have to use this equation CRR 7.5 into MSF into K sigma into K alpha. This MS factor we can identify by using 10 की power 2.24 upon MW into MW की power 2.56. Here MW we are using whatever magnitude we had considered. After that, this is the factor of safety, CRR upon CSR. This is the one method which I used. After that, this is the second method. Similarly, in this method also they had given R upon L. R is just CRR and L is just CSR. L is CSR. For R calculation, they had given these three equations, and after that R1, R2, and this is the R3. And after that, for L, it is same as this previous IS code method. Only the RD factor, which is stiffness reduction factor, is varying here. After that, this is China GB code. China GB code is basically mainly dependent on the SPT values. For any according to the PGA values, they had given specific this reference SPT value. From those reference SPT value, we have to find out the critical values, and by using these critical values, we have to find out this liquefaction potential index. They had given one separate equation. This is the equation. By using this, we get in those two methods we are getting factor of safety. Here we are getting directly liquefaction potential index values. After that, my last method is Bollinger-Idris method. Here is also factor of safety CR upon CSR, and this is the calculation equation. As we see in IS 1893 code, Japanese bridge code, and all these factors are varying with some empirical relations. Here RD factor is in all three methods. RD factor calculation is varying. Look at here. Here RD is just e की power alpha z plus beta into z. They had given separate equations for this RD calculation. Similarly, in this just a minute. Here in IS 183, they had the separate RD stiffness reduction factor values. After that, in Japanese bridge method also, they had given RD is equal to minus 1.015 into Z. So all these methods have, in CSR calculation, they had difference in this RD calculations, stiffness reduction factor. Apart from this, in Japanese bridge code method, they had given one separate equations for Amax also. But as I am using constant value for 0.24 and 0.36 G as a PGA value, so I had not used this equation as a Japanese equation in Japanese code. So in Bollinger method for CRR calculation, they had given this equation. All these equations are, they had given around more than 140 field case histories, and all those field case histories, they had given these equations for calculation of CRR values. So as we are getting in terms of factor of safety from IS code method and Japanese method and this Bollinger method, and Chinese code is given a liquefaction potential index value. So in Iwasaki in 1970 had given one equation to convert factor of safety into LPI value, because LPI value is giving the this liquefaction potential index for entire stretch of the column soil depth. So I use this equation for to find out the LPI value, and based on this LPI value, we can identify which zone is. If we are getting more than 15 LPI value, we are getting very high liquefaction potential index. After that, 5 to 15 is relatively high, and below 5 it is very less chances of liquefaction. So now directly I am coming to my graphs. This is the equation. This is the curve for Bollinger reduced equation. By using all those equations I calculated. After that, this is the curve for Japanese bridge code method. This is for Chinese bridge code method, and this is for IS 18393 code. One very important thing I observed here, that when we are going for silty soil with have some cohesion, we are getting more LPI values in IS 183 code. But when we are going for cohesion-less soil or very less C values, basically we can say cohesion-less soil, we are getting LPI value higher for Japanese bridge code method. As we see here, this is the reason where soil is cohesive nature, means somewhat cohesion is there. After that, this is the reason where soil is cohesionless. So here IS code method. In next graph also same thing will come. This is the second graph. Here at 6 meter depth we are getting very less value of SPT, so directly this LPI value shoots for this Chinese code method, because Chinese code method is basically mainly dependent on the critical this SPT based method, SPT values. But this is the cohesionless stretch of the soil, and you see Japanese bridge code method is giving very higher depth, means very conservative results they are giving. This is the third bore holes with 6.9 magnitude, 0.24 G. Here also Japanese bridge code method is giving very highest value, because this reason is also, this soil is also for cohesionless soil. After that, this is the Digwara reason for, here you see, here also this reason is well cohesive reason. Here we are getting higher values for this IS 183, and after that cohesionless soils are there. Here we are getting for Japanese bridge code method is giving more conservative results. Similarly, I calculated all these equations for 7.5 and 0.36 G PGA value, and here one very interesting thing I observed, that this Bollinger method initially giving very less LPI values, and with increase in this PGA value, it shoots very high, means 200%, 300 up to 300% also it shoots in their LPI values. This is the observation I got here. In all four graphs, these are the things. And one more thing, if we are increasing the PGA values, this Chinese code method is not giving that much increase in this LPI value. Chinese method is less susceptible to this increase in magnitude of PGA. So we can observe this here. This similarly in this graph also you can see Chinese bridge code method is giving LPA value of 3.1, around 3.1. Now these are the conclusion I already made. That for cohesionless soil, Japanese bridge core method is giving very high conservative results, means higher depth of liquefaction. After that, in case of C5 soil, in C5 soil also it depends on many factors for liquefaction like liquid limit and plasticity index, percent of fineness. But here in the soil parameters which I use, all these parameters are giving in relevant range, and based on that I found that IS 183 2016 method is giving more chances of liquefaction compared to other methods. Similarly, there is the highest percent change if we are increasing this PGA value up to 0.36. Bollinger Idris method is giving more LPI value. After that, Bollinger method, from these graphs we can easily identify that, but with higher magnitude of this factor of PGA, this Bollinger method is giving very better response and consistent safety factor compared to other methods. Apart from this, as we increases the depth up to 20 meter depth, after 20 meter depth, this liquefaction potential index value is decreasing very drastically, and after 20 meter depth we are getting very least chances of liquefaction. Okay, these are the last code. With increase in PGA values, Chinese code method is giving very less increase in LPI values. And these are the references which I followed. Okay, thank you so much.
Thank you very much. Any questions about liquefaction? You considered only cyclic liquefaction. Have you heard about static liquefaction?
Yes, sir, I heard, but I had no.
So it's
we are
not the subject of your considerations. Okay. If there are no questions, thank you very much.
Thank you so much.
Very nice presentation. Are there any presenters online?
Yes, sir. Am I audible?
Hello, is there anybody online?
Hello. Yes, sir. So shall I start, sir?
Yeah, what's your name?
Nongmaitem Anand. Paper IT 128, 128.
120.
128, 128.
128 है सर. He's in the wrong session.
I'm afraid that's not the right session.
Yeah, actually you have logged into a different session. Your session is not in this room.
Okay, sir. I was actually given this link. Okay, fine, sir. I'll log out from this session. I will try to contact the organizing team.
Yeah, it is in session 4.
Actually, I was.
Okay, we can allow for this presentation, but
Okay.
I'm not sure whether this is the right audience.
So it is
Yes, sir, that's true.
128, right? Yeah, okay.
128. So I was actually given this link to log in. So
Okay, so this it should be the session number 4. There is.
all right, sir. Yes, sir. I'll log out from this. I'll log out from this session. I'll try contacting the organizer. Sorry for the delay and
room number 1. Room number 01.
Okay.
You should connect there. But if you can't connect there, please come back.
Yeah, actually, I'm not able to connect. I am only getting this link.
इसको देखिए. Hello, is there anybody else online? KRD. Yeah, what's your name?
Deepasri Sharkar.
What is your paper ID?
107.
107. Okay. Yes.
Okay, we've got you on the list. So
I will leave the session.
Okay. Yeah. Before
Yes,
that,
please.
can I request Mr. Anand, could you please log out and unshare your screen?
Sure. Sure, sir.
Yeah. So Deepasri, you can share your screen and start the presentation.
Okay, sir.
Okay, so I guess the next presentation is titled A Study of the 3D Consolidation Characteristics of Bottom Ash-Treated Soil, Emphasizing Vertical and Radial Drainage Paths. And there are two authors, Abhijit Debnath and Deepasri Sarkar.
Yes, sir.
Please introduce yourself. Deepasri Sarkar will be presenting. We're happy to have you here with us. That's the right session.
Good evening, everyone. I'm Deepasri Sharkar, MTech scholar NIT Agartala, presenting my experimental study titled Consolidation Characteristics of Bottom-Mesh
Sorry,
Treated Soil
we
Emphasizing.
can't see your presentation in full.
Okay, sir.
Please switch into the full screen mode.
Yes, sir, I have. Yes, sir.
Oh, it's happening, I hope.
Okay, sir. Thank you. So this is my paper ID 107, entitling as A Study of the 3D Consolidation Characteristics of Bottom-mesh treated soil, emphasizing vertical and radial drainage. These are the contents that I am going to present today. Due to compressibility of soil, when soil mass is applied load, the expulsion of water happens, and that is called consolidation. Consolidation phenomenon was primarily thought as 1D, and thus its assumptions were as follows, and then later expanded to 3D consolidation, as 3D consolidation is more practical in field. Bottom-mesh is byproduct of combustion in coal industry, specifically formed solid residue of the bottom furnace, including the mineral impurities and imbustible contents. Effect of bottom-mesh in consolidation is mainly due to the particle size distribution of the bottom-mesh, and due to that the void ratio and the porosity of the composite material and gets affected, and shear strength also gets affected. The compressibility of the soil between soil bottom mesh mixture may differ from that of the original soil. These are the literatures that I have followed through for these experimental studies. Some of the importance are Icgeid 2016, influence additives on stabilization of soft clay soils. Lashkar and Pal 2017, effect of anisotropic flow of water on consolidation behavior of silty clay soil. Then Lashkar and Pal in 2018, assessment of 3D consolidation settlement of soil by considering the effect of surcharge pressure. Then Cole et al. 2023, a comparative study on consolidation of clay using laboratory automated and fabricated 3D consolidation apparatus. These are the salient features from the previous studies that I have found out. In 3D consolidation, compressibility and rate of consolidation soil decreases with increase of surcharge pressure on the surrounding soil. Soil gets denser with the increase of surcharge pressure on surrounding soil. These are some of the key points that I have collected from the lecture notes and the literature reviews that I have just found and shown here. Objective of the present study is to study the consolidation characteristics of silty clay with sand soil in fabricated laboratory 3D apparatus. To study the characteristics of silty clay with sand soil with different drainage condition, radial, vertical, and combination of both. And then to study the consolidation characteristics of soil with different percentage of bottom mesh as 10, 20, 30, 40% with no bottom mesh used in the mix. Comparative study between 3D consolidation apparatus and 1D oedometer to study the consolidation characteristics of soil with different surcharge loads. These are the on-screen currently material properties of my soil and bottom mesh. The soil with OMC 21.12% and MDD of 12.30 kilonewton per meter cube as nomenclatured by CH soil, clay silted sand soil. Then these are the properties of bottom mesh that you can see currently on my screen. So this is the experimental setup that I have used and fabricated in the laboratory for the 3D consolidation apparatus. So mainly a cast iron box of 12 centimeter into 12 centimeter into 12 centimeter is used. Then solid steel plates are placed along with the soil boundaries to obstruct pore water drainage, and porous stone plates are used to allow open drainage path. As I already mentioned that I have controlled the different drainage paths in 3D consolidation, at least I tried. A 3.60 centimeter diameter perforated loading plate is used to apply the vertical footing load on top of the soil surface. Here you can see in this figure, in this diagram, this is the model that I have used in this experiment. The 3D consolidation apparatus that fabricated in laboratory, which I have just shown, is set in such a way that soil sample follows a 2:1 stress distribution method throughout the testing. For all the tests performed, a sitting surcharge pressure of 20 kPa is applied throughout the experiment to impose the effect of actual field conditions. And this is the drainage paths that I have mentioned, that I have used porous stone plates and steel plates to control vertical direction, radial direction, and vertical and radial both direction. These are the two figures. One is 1D oedometer test, and this is the 3D consolidation apparatus, which is fabricated and earlier shown the full picture. Now, jumping to the results and discussions of my experiment. So, variation of void ratio with the pressure range curves for the different flow condition in 3D consolidation test. So, in this experiment, throughout the experiment, I have used 20 kPa sitting surcharge pressure, and the porous stone plates were changed and used as such that I can control in drainage in one test throughout, and then for two direction, and then for one direction. And the result, I observed that a decrease of 3.31% in the void ratio for pore water drainage along all three paths when compared it with the drainage path allowed in only one direction, indicating the increasing of settlement. This is the next experimental result that I have observed, which is variation for CV for varying drainage conditions in 1D oedometer test and 3D consolidation test for the same material. And in 3D consolidation test in the fabricated apparatus that I found that CV decreases with the decrease in path allowed for the drainage in consolidation, which shows the drainage in all directions has the maximum CV and lowest in when drainage in only one direction. And 1D consolidation in oedometer is less from all of the 3D consolidation. Specifically, I have compared 1D consolidation with drainage in two directions, which is radial direction. And I have found that CV in 1D is less than the 3D. And results exactly I have included in the screen, you can see currently. Then variation of CV for the different percentages of bottom mesh mixed with soil in 3D consolidation test. Earlier tests I have tried to control the drainage paths, and in this experiment I have used all directions open throughout the experiment in for all 5 of the experiment, when 0% bottom mesh mixed with the soil, same soil that I have used earlier, then 10, 20, 30, 40%. And from this experiment I could see that 40% bottom mesh, when maximum it is used, CV was increased highest, and lowest when 0% bottom mesh was increased, 0% bottom mesh was used. And throughout the experiment, for maximum vertical pressure of 3.20 kg per centimeter square was used. You can see the graph that I have included here. So now the conclusions of my experimental study. The experimental investigation shows these following conclusions that is currently on my screen. Varying flow conditions greatly influence the consolidation process. Settlement decreases as the rate of pore water drainage reduces. Compared to pore water drainage allowed in all directions, the void ratio decreases by 3.31% when the drainage is permitted only in one direction. The compression index increases as the void ratio decreases for a particular drainage condition. CV decreases as the outflow of water is restricted during the test. When flow condition changes from allowing drainage in all directions to vertical direction only, which is one direction that I have mentioned in my graph, CV decreases by 13.70%. CV and consolidation rate are higher in the 3D consolidation test and lower in the 1D voidometer test. CV increases with the increasing amount of bottom mesh in the soil mix. CV increases by 31.10% when 40% bottom mesh is mixed with soil, comparing to soil with no bottom mesh. The consolidation rate increases with the percentage of bottom mesh in the soil mix. These are the references that I have used for both in this presentation and the paper. Thank you.
Thank you very much. Any questions to our nice presenter? No. Please.
Hello, can you hear me?
Yes, sir.
It's nice presentation. I would like to know, see your setup for 3D consolidation and how you are applying the pressure and how you are measuring the deflection.
Yes, here my screen is visible.
Yes.
Yes, so this is the fabricated model. You can see the cast iron box that I have mentioned is here in the middle, and from inside the box in all directions I have used stone plates, porous stone plates, and in all sides to control the drainage, and steel plates when I didn't want water to flow in particular direction, as I have tried to control the drainage paths. And this plunger here, I have applied load through this plunger, and water from this, you can see the apparatus, and through this dial gauge I measured the deflection. Sorry, the settlement. And the consolidation further I have completed.
You are applying the load only in the vertical direction, right? Hello?
Yes, sir.
So you are applying load only in the vertical direction, but drainage is
Yes,
allowed
sir.
in all the directions.
Yes. The load is applied only in the vertical direction, and on top of this cast iron box, the footing is applied, which is I have used here in 3.60 centimeter. A perforated loading plate is used here on top of this box, and you can see the cast iron.
Yeah, that's fine. So deflection
Yeah.
only you are measuring in the vertical direction, and load is also in
Yes.
the vertical direction, but
Yes.
drainage is on all around.
Yes, drainage is allowed. I have used steel plates when in 2 directions, then drainage was allowed in only 2 directions. 4 directions when I put the steel plate, then drainage allowed in only 1 direction. And when only
Okay,
one
thank
direction
you.
was open.
Okay.
Okay, thank you, sir.
Thank you very much. Thank you. Very nice. Any other presenters online? This one.
Sriti Debbarma, are you online? Hello. Yeah, but she's not responding. So message किया जा सकता है क्या? उनको मैसेज करें क्या रे ऑनलाइन हो? और ये
So the author is logged in but not present.
Hello, sir. Deepashri here.
Yeah, you will log
Sriti and I am from same college. So can she present from my?
Yeah, fine. No.
Yes, please.
As she's facing some network issue in her laptop. Hello.
Hello. कुछ लिखा है क्या? इसका लिंक मुझे और एक है जिसको लिंक कैसे भेज पाएंगे? मैं नहीं है इसमें मैं नहीं है.
Concentration. They are in the classroom.
इसको मैसेज नहीं करना चाहिए.
सर उनका मेरे यहाँ पर ऐड कराना है.
Personal satisfaction that
Connections.
was the money. सर आपके मेल पे भेज दूं?
ये नाम आएगा तो मेल आईडी छड़ा तो नहीं आएगा.
So what about the presentation?
Hello. Is he joining, Deepasri?
Yes, sir. Can Sriti present from here?
Okay. Please ask her to start.
Okay, sir. Okay, sir.
हाँ ABI अभिमान ABIMAN @ 9069 @gmail.com. मेल आईडी हाँ
उनको ये चला गया. ठीक है.
जैसे
भेज दिए. हम भेजे.
ABA. Then ABA MN 9069. ABA MN
69 at the rate gmail.com. 9069 at the rate gmail.com. Gmail.com. Invite. Hello. Please check the invitation.
So distracted TV.
Good afternoon, everyone. I'm Hello, sir.
Can we expand the screen to the full? We can hear you, we can see your presentation, but oh, yes, great.
Shriti, you can think of downloading this and then presenting it via PowerPoint rather than being on Chrome. It would be better if you just download and just open it on PowerPoint.
From beginning. Good afternoon, everyone. I'm Sriti Devar, my MTech scholar from NIT Agartala. I would like to thanks for giving me opportunity to present on Icgeid 2024. My paper title is Experimental Investigation on the characteristics of software using nanometrics. These are my content. Introduction. Expansive salts are the salt which has the tendency to increase the volume in the presence of water and decrease in the volume in the absence of water.
Sorry, I must interrupt you because the slides don't change. We still see the first slide on the screen here in the room where we are on the conference. So something doesn't work. Please take your time. It'll be okay. Okay? We'd like to see your presentation in full.
Is this?
Hello. Hello. Please unshare and reshare again. Okay. Please. Hello. Are you there? Hello.
Yes, sir.
Yeah. So please unshare and reshare again. Okay.
Okay, sir. Minimize করে দিন। লিভ করো।
Your slide is not working. उसी में दूसरे जन दे रहे हैं ये, ठीक है, इसको म्यूट कर बता दीजिएगा, एक्सप्लेन कर देंगे कहाँ से ये आएगा, म्यूट कर दिया उसको। लेकिन अभी जिसको इन्विटेशन पे भी तो नहीं आएगा, आनंद बोल के जो बोलेंगे उनको भी भेज देंगे। दो तो है अभी इसमें, ये हमारा रूम का नहीं, ये दूसरे रूम का है। ठीक है, इसका लिंक उसके पास गया, उसका लिंक उसके पास भेज देंगे। अभी जिसको ये भेजा ना, हाँ, उसको तो इधर नहीं दिख रहा है। स्टूडेंट कौन कोऑर्डिनेट कर लेगा, उसके पास नहीं है, उसके पास ईमेल आईडी भी नहीं है। ये सर इनका तो हो गया, बार बार नहीं नहीं, वो ओपन कर रहा है दूसरे का, ये प्रेजेंटेशन।
Oh, it's very promising. Yes. Thank you. It's all done. We're happy.
Visible?
Yes. Yes. Please start your presentation. You may talk now. Thank you very much.
Okay, sir. Good good afternoon, everyone. I'm Sriti Deburma, MTech scholar from NIT Agartala. I would like to thank for giving me opportunity to present on Icgeid 2024. My paper title is Experimental Investigation on the Characteristics of Soil using Nanochemicals. These are my content. Introduction. Expensive soils are the soil which has tendency to increase the volume in the presence of soil and decrease in the volume in the absence of soil. The behavior of expensive soil is due to the presence of clay-like monolinate, elite, and culinate. Expensive soil has very low bearing and high shrinkage and high swelling characteristics. Considering problem account infill construction establishment technique have been used to improve their engineering properties. Soil stabilization is a technique used in civil engineering to modify and improve engineering properties of soil. Soil properties can be modified with the use of modern technique. The latest innovation in the field of soil stabilization is the use of nanotechnology. Nanotechnology has emerged as a sustainable ground improvement. It is a branch of science that deals with particulates on a nanoscale and play a vital role in the behavior of soil with various properties. This is my objectives. The objectives of the present study include to find the optimum doses of terrestrial and jacoban, to determine the physical and designing properties of undisturbed soil, as well as after adding nanochemicals with different proportions to determine the nanochemicals additives different effect on moisture susceptibility in soil mix prepared with and within nanochemicals to determine the uses of soil treated for the optimized doses of nanochemical stabilizer. These are the literature review I followed. Kumar et al. 2018 evaluated the effectiveness of one of the new commercial stabilizer. They observed that by using stabilizer, there is nanochemicals and cement, it reduced the quantity of soil that can be used in non-traffic zone as well and minimize the permeability at great extent. Raghavendra et al. 2018. They studied the behavior of black cotton soil using nanochemicals. They found that unconfined compressive strength has been decreased when the doses of the nanochemical is increased. This was Sarkar 2019 studied the effect of stabilization of subgrade soil using nanochemical and fly ash. They found that using nanochemical and fly ash, it reduced liquid limit and plastic limit, while the severe value increased significantly. Padmavati et al. 2019 present the use of nanochemicals and cement at admixture. They observed that terrestrial gives water tightness to the product where Jacobon control erosion, dust, and fatigues. Ambekar and Sahane 2019 examined and found that addition of fly ash and steel slag in black cotton soil reduced its shrinkage, swelling, and improved its properties. Parsner et al. 2021 studied the behavior of expensive slag using nanochemical. The test results saw the addition of terranation reduced swelling potential, shrinkage, free swell index, and increase unconfined compressive strain and maximum dry density. Mohan and Swami 2022 investigated on the improvement of soft ground using nanochemical stabilization. By using these nanochemicals, test results showed that usage of stabilization increased with the increase in nanochemical doses, but the increase in strength was up to a high specific doses and further the growth rate decreased. Methods and method. Black cotton soil is susceptible to swell when water is present and stream when water is eliminated. This figure 1, this is the soil sample I have used, black cotton soil. This table 1 show the soil properties. 10% test 9.5, silk 55.59%, clay 34.90, specific gravity 2.38, liquid limit 61.25, plastic 32.10, plastic index 29.15, optimum moisture content 31.5, and maximum dry density 13.33, and compact compression strength 238.90. Terrestrial is a nanochemical and nanotechnology-based product produced in Gujarat, India by Zydex Industries. Terrestrial is a water-soluble, ultraviolet, and heat-stable reactive soil modifier. It is available in the liquid concentration that must be diluted with water before being applied to soil. Table 2 show the technical specification of terrestrial. Its appearance is pale yellow, liquid density 1.01 gram per ml, press point greater than 80, and freezing point 5 degree. Zycobon is a submicron acrylic copolymer emulsion with a bonding particle life of more than 10 years. It disperses in the soil, connecting the soil particles and providing soil erosion resistance, dust management, and fatigue resistance. Table 3 show the physical and chemical properties of Zycobon: color, transparent, odor, faint odor. And figure 3 show this is the figure of Zycobon. Meteorology. This investigation attempt to increase the engineering properties of expensive clay soil improved with nanochemicals. In the first step, the subsequent experiments were done on black cotton soil, sieve analysis, table limit, compaction characteristics, and unconfined compression strength. In the second step, black cotton soil was treated with distinct combination of nanochemicals and various doses as 0.03%, 0.06%, 0.08, and 0.1 by means of weight of dry soil. The mixer then accumulated acid in different air flask for 24 hours by mixing soil with aqueous chemical, and OMC for even mixing of soil and chemical with soil particles. Figure 4 saw the symmetric diagram of experimental arrangement. First, literature survey and formulation objectives is after that collection of sample soils and chemical determination of index properties of soil at a limit and specific gravity, that is determination of engineering properties of soil, compaction characteristics, and unconfined compressive strength. Procure nuclei and to obtain optimum doses based on a specific gravity, plastic, and compaction. The response of optimal nuclei on all geotechnical properties of soil, result, and discussion after the last conclusion. This is my result and discussion. Effect of nanochemicals on unconfined compressive strength. Figure 5 show the variation of use test result with various doses of nanochemicals are shown in figure. In figure, we can see 0.08 percentage soil treated with 0.08 percentage of terrestrial. The unconfirmed strength is maximum. Result of black cotton so with different doses of zygopan and combination of nanochemical. Results show increase in unconfirmed compressive strength with terrestrial zygopan and combination of both with optimal doses as 78.19%, 73.33%, and 115.46% for 7 days of curing. Effect of nanochemical on arterial limit and complexion characteristics. The liquid limit, plastic limit, and plasticity index were finalized as per IS 2720 Part 5. From figure, in figure 7, show the variation of arterial limit with addition of different nanochemicals. This is the optimum doses are taken, and from here we can see plasticity index is decreasing when we treated when soil is treated with nanochemicals. The standard Proctor test has been performed with accordance with IS 2720 Part 7 1980 and established the relationship between optimum moisture content and maximum dry density. It was obtained that addition of different nanochemicals substantially change complex characteristics of soil. This result is 20.63% decrement of optimal moisture content and 7.65% enhance in maximum dry density. When soil treated with nanochemicals, maximum dry density is increasing and water content is decreasing. Effect of nanochemicals on free soil index. In accordance with FCI, soil value of soil was categorized as very high expensive soil. Results show reduction in figure 9. It showed the free soil index result of black cotton soil with nanochemicals. Results show reduction in soil expansiveness with optimal doses of terrestrial zygopan in combination about at 9.19%, 6.77%, and 13.90% respectively. These are my conclusion. In this study, the experimental result on high expansive clay with variety of nanochemicals with different doses on index and engineering properties of soil has been explored. The incorporation of nanochemicals into soil result in a change in both the liquid limit and plastic limit. The plastic index is reducing, leading to the enhancement in the workability of clay. The compaction parameter of the treated sample exhibit an elevation maximum density in conjunction with a reduced optimum moisture content. This observation may be attributed to the mutual effect the water probing layer and enhance workability. The strength characteristics exhibit a significant increase rising from 238.90 to 765.93 km per meter square and 745.01 km per meter square and 926.13 km per meter square when subjected to 0.08% of terrestrial and zygopan and combination of both 0.08% terrestrial and 0.08% of zygopan. Over the 7 days curing, use of nanochemicals saw reduction in free soil index values with the optimum doses of nanochemicals and combination of both 9.19 and 6.77 and 13.90% respectively. Nanochemicals provide a hydrophobic barrier on the soils of surface of soil particles, hence lowering the affinity among the soil particles and water molecules. There exists a potential for future exploration enhancing the index and engineering properties of black cotton soil through the utilization of various combinations of nanochemicals and doses. Hence, determining it is suitable for high use in highway construction. These are my reference. Thank you.
Thank you very much. Do we have any questions to the presentation? Very nice. No? No, there are no questions. Thank you very much once again.
Okay, thank you, sir.
Thank you.
Hello, sir.
133. Okay. So there is one more presentation titled Assessment of Behavior of Footing Resting on Dispersive Soil Stabilized by Fly Ash Amended Red Mud.
Yes, sir. Myself, I am ready, sir. Hello, sir.
And the presenter is Abhilash K.E.
Yes, sir. I am here, sir. I am here.
Please share your screen. Show
Okay.
us your presentation.
Okay, sir. Is it visible, sir?
Yes, perfectly.
Okay.
Thank you.
Good evening, everyone. Myself, Abhilash K.E. from Karnataka, and I'm a research scholar. And I would like to thank everyone who are directly and indirectly responsible for giving me opportunity to present my presentation over here. And my technical seminar is on the title Assessment of Behavior of Footing Resting on Dispersive Soil Stabilized by Fly Ash and Amended Red Mud. And this is the content, introduction, need for present study. Am I audible, sir? Hello? Am I audible, sir?
We can see the first slide of your presentation.
Okay.
And when you pass to the next one, full screen was lost somehow.
Is it visible, sir, now?
We
Contents.
see the PowerPoint with your presentation, but it's not in the presenting mode.
Okay, I will do it once again, sir. Okay. Screen. Click ಮಾಡಿ share ಮಾಡಿ. The presentation. Is it visible, sir?
Nothing changed.
Sir, no, sir.
No, we can see changing slides, but not in the presenting mode. Please switch into the presentation mode.
Is it okay, sir?
Well, yes, now I think it's okay.
Thank you, sir. And this is the content, introduction, need for present study, methodology, and it is then followed by result discussions, conclusions, and reference, and introduction regarding. So regarding dispersive soil is basically a highly erodible and the soil which is highly susceptible to erosion, because since it contains very high amount of accessible exchangeable sodium ions, by that it could not get to proper burning, so that it will be subjected to erosion, and we could able to see so many severe damages in case of hydraulic structures, canals, embankments, especially the foundations over which are constructed over in this type of soils. And it is abundantly available in the large mass, especially in the southern Karnataka. And this is the need for present study to enhance the engineering properties of such soils, and also to have the mitigation of disposal problems associated with the industrial byproducts such as fly ash and red mud. and also to build the durable and sound structures. When these soils are encountered, when it is not easily acceptable to construct the buildings or any civil engineering structures, obviously we need to make some foundation treatment. Unless it is treated, we cannot build a suitable foundation. So that we need to make sure that it is durable and sound for the construction activities. And this is the property of the soil, fly ash and red mud. And the soil belongs to the silty sand, that is SM. It is having a liquid limit of 42% and a plastic limit of 90, and whose compressive strength in undrained manner will be 48 kPa. And the red mud, which is obtained from the aluminum industry, that is Hindalco Private Limited from Belgaum, Karnataka state, and fly ash from the locally available supplier. And this is the methodology, the collection of materials, characterization, that means conduction of experiments as per the relevant codes, especially the index and strength properties. And the strength property, nothing but the UCS is conducted for the soil just by having the fly ash alone is added from 3 to 12%, and red mud is varied once the fly ash is optimized. After optimization of fly ash, the red mud is amended with the fly ash at optimized value, that is 9%, and the usage is conducted. And once the properties of dispersive soil is found out, the assessment of footing over the example, the square footing resting on untreated and treated dispersive soil is analyzed through the Plaxis 3D software. And this is the result. And we could see with the increase in fly ash content, we could see that the increase in MDU is also there up to 9%. And so as to get the optimization percentage of fly ash, I had conducted the usage test of the samples which are cured at 7, 14 and 28 days. And in all the curing period, for 9% of fly ash content, the usage is found maximum, and hence the optimum content of fly ash is taken or considered as 9%. And further, in order to have what could be the probable effect even after the red mud is used. So in this case, the soil is further treated with 9% of fly ash, that is obtained as optimum fly ash content. And the red mud is varied from 5, 10, 15 and 20%. Here also we have got with 9% of fly ash, which is amended with red mud up to 15%, the MDU is increased and OMC is reduced. And for 15% of red mud with optimum fly ash content, the strength has been increased from 48 kPa to around 220 kPa for 7 days, and it is around 320 for 14 days. For 28 days, it is around 420 kPa. This is the thing. And based on the results obtained, the compaction and UCS, I could get some values of the Young's modulus based on the stress strain curve. And I have got some values of Young's modulus. Why I need Young's modulus means once the soil is stabilized, and whatever the stabilized soil parameters that I had used it for analyzing, example, a square footing is resting on such soils, say the footing width of B and depth as 1 meter, and I had analyzed by having the boundary conditions of having the depth equal to 4B and the length, or say the width of soil, it is limited to 8 times of the breadth of the foundation, and the boundary conditions are fixed. And once the soil is treated with red mud and fly ash in the different percentages, this R5, R10, R15 and 20 indicating the different percentage of fly ash and red mud which is added, and these are the parameters which are used in the analysis This analysis is done using the software Plaxis 3D. And first I analyze the, are you getting, sir? Hello?
Yes.
Yes, okay. Shall I proceed, sir?
Yes, please.
Okay. Once I got the values of Young's modulus, compaction characteristics, and along with the phi and mu, this mu indicating the Poisson's ratio for the treated soil. So I kept 1 meter, 1.2 and 1.5 meter as the footing width, and I could able to get the settlement for dispersive soil, which is alone without treatment. And when the dispersive soil is treated with optimum percentage of fly ash with 5% of red mud with the 10 and 15, right, like that, I had analyzed for 1.2 meter and 1.5 meter in all the cases. That means for footing width varying from 1 to 1.5 meter, I could see that in untreated soil or origin dispersive soil, the settlement is being increased, but the reduction is seen if we add up the binder content up to 15% and the corresponding this value indicating R5, 10, 15. So for 1 meter, the reduction is 13%. It is 19% reduced. The settlement is reduced for red mud with 10%, and for 15% it is 24%, and so does with the footing for 1.2 meter and 1.5 meter. And coming to the next slide, this slide is also the continued part of that. And in this slide, these three curves indicating the low deformation characteristics for 1 meter, 1.2 meter, and 1.5 meter width of the footing provided. This is only for the dispersive soil, which is untreated. And I have taken only 1 meter of footing width and I have analyzed it for different percentages of addition of binder content. And this is for again 1.2 meter and what could be the effect of settlement and all. I had calculated it as a whole for 1.5 meter footing width also, and I could able to get that the reduction in settlement is maximum for 1.5 meter footing, and for 1 meter it is around 24%. And these are all the conclusions I have drawn from the present study. As we know, the fly ash is used as a stabilizer alone, and the OMC and MDU is increased with OMC decrease up to 9% of fly ash, and hence the same values has been obtained, used for getting the samples for getting the uses. And from uses, I could find 9% as the optimum. And when the fly ash is optimized as 9%, and the further the compaction and red mud is also varied, compaction and uses tests are conducted based on optimum fly ash content as 9% and red mud varied at 5% increment from 5 to 20%. And we could able to see the red mud is found effective up to 15% when it is coupled or amended with 9% of fly ash. And along with that, the Young's modulus of FARM fly ash red mud treated soil is improved with the increase in binder content. And again, the optimum percentage of red mud is obtained from UCS, that is 15%. And the load settlement curves of a footing resting on treated soil obtained from Plaxis 3D has indicated some significant reduction in the settlement when the load is subjected on the footing from 10 kPa to 450 kPa for all the footings. And these are the conclusions I got, and this is the reference. And
thank you very
thank
much.
you.
Thank you very much.
Thank you,
Very
sir.
nice presentation.
Thank you.
Any questions to our nice presenter? No? Okay. Thank you very much once again.
Thank you, sir.
Any other? This was the last presentation. Thank you. Oh, We are nearly on time. I thought that we would finish a long time before the scheduled time, and it's not that way, in fact. So would you like to summarize our session?
So it was a very good session, starting with the lead lecture given by Dr. Jha. It was really informative. I have limited experience in soil. All that I have learned regarding soil was at IIT Bombay, and it was like a refresher course for me. Thank you, sir. And then all the participants have contributed to the common theme of ground improvement and containment remediation. We have seen research on black soils, on red soils, and all kinds of waste materials, right from fly ash, bottom ash, alumina waste, and it was really informative. I hope that all of you have really taken out something for your further research, and it was an honor co-chairing this with the chair professor, Professor Christoph Sternik. Thank you.
Thank you too. Thank you very much.
Okay, so thank you both the chair and co-chair, Professor Kristen and Dr. Nikhil. And thanks to all the speakers, including theme speaker. Now, before we end the session, I request Professor Christoph to come forward. We have a small token of gratitude to our theme speakers. At first, Dr. Arvind Kumar Jha. Yeah. For me. Yes, once again, it's for you. Now, can I invite Mr. Saurabh Rajput from McAfee for his presentation? We have a bouquet for him. Can I have the bouquet? Okay. Now, for the with our events pleasure and thank you for on behalf of the institute and organization. We have one more for the co-chair. Yours. Thank you very much. Thanks for. So thank you everyone, and special thanks to the chairs. Yeah, so all the speakers, if you can gather here, we can have a group picture along with the chair and co-chair. Let the business.
You are taller, na? Taller some के ज़्यादा. ठीक है. हमारे विशेष कौन सा है? It's a traditional dance from Church India. It will be let's say one of the